What if everything we perceive as the universe, the swirling galaxies, the silent dance of planets, the invisible pull of gravity, is not just a vast and mindless machine, but a living, thinking entity? Imagine for a moment that the cosmos itself possesses a form of consciousness, an awareness that transcends our human understanding. It's a concept that sounds more like science fiction than science, yet some of the greatest minds in physics and philosophy are beginning to take this idea seriously. We're not just talking about distant speculation. We're venturing into a realm where the boundaries between observer and observed, between mind and matter, begin to dissolve entirely. This is the mysterious and compelling territory of quantum consciousness, and it challenges everything we thought we knew about reality. As you gaze up at the night sky, have you ever felt a strange sense of connection, as if the stars themselves are looking back at you? That intuitive feeling might be more than just poetry. For centuries, humanity has grappled with questions about our place in the cosmos, but now, groundbreaking theories are emerging that suggest consciousness may not be confined to biological brains. Instead, it could be a fundamental property of the universe, woven into the very fabric of space and time. From the bizarre behavior of particles in quantum experiments to the awe-inspiring complexity of cosmic structures, there are hints, whispers really, that point toward a deeper, more participatory universe, one where mind and reality are inextricably linked. Today, we embark on an extraordinary journey through 30 captivating theories that explore this profound possibility. Together, we'll dive into ideas that bridge the gap between cutting-edge physics and age-old philosophical wonder, from the implications of quantum entanglement and the observer effect to revolutionary models proposing that consciousness itself might be the key to understanding the cosmos. This isn't just about abstract concepts, it's about reimagining our relationship with existence. So settle in, open your mind, and get ready to explore some of the most thought-provoking and mind-expanding ideas ever proposed. What you're about to discover may forever change how you see the universe and your place within it. Our journey begins with a theory that fundamentally reimagines the role of the observer in the cosmos. It's called the Participatory Anthropic Principle, proposed by the renowned physicist John Archibald Wheeler. He presented a vision of the universe that is not a pre-existing, static stage, but a dynamic and unfolding phenomenon that requires participation. Wheeler suggested that we are not merely bystanders in a cosmic drama that would unfold with or without us. Instead, our act of observation is a crucial part of the process that brings tangible reality into being. This isn't a metaphor, it's a proposal grounded in the bizarre, counterintuitive behavior of the quantum world. To grasp this, we need to look at one of the most famous experiments in all of physics, the double-slit experiment. In its most basic form, scientists fire tiny particles like electrons at a barrier with two slits in it. When no one is watching, these particles don't behave like solid little bullets. They act like waves, creating an interference pattern on the screen behind the barrier, as if a single electron is passing through both slits at once and interfering with itself. This is the strange state known as quantum superposition, where a particle exists in multiple potential states simultaneously. But here's where it gets truly mind-bending. The moment a scientist places a measuring device at the slits to see which one the electron goes through, the behavior changes instantly. The wave-like interference pattern vanishes. The electron now acts like a single, definite particle, choosing one slit as if it knew it was being watched. The act of observation, of measurement, appears to force all those swirling possibilities to collapse into one concrete reality. Wheeler took this stunning implication and ran with it, arguing that this isn't just a laboratory curiosity. He proposed that this phenomenon scales up to the entire universe. In Wheeler's view, the universe has existed in a fuzzy, unrealized state of potentialities, a vast cloud of possibilities, for billions of years. It is only with the eventual emergence of conscious observers, beings capable of asking questions and making measurements, that the universe achieves a concrete form. In a very real sense, we are participants in creation, looking back at the cosmos and, in the act of looking, solidifying its history and its very existence. It's a profound and humbling idea that places consciousness not as a minor byproduct of the universe, but as a central player in its very foundation. But if observation truly brings the universe into being, where does that consciousness itself come from? This brings us to a theory that tackles the very source of awareness, proposing an answer that is as elegant as it is radical. Developed by the mathematical physicist Sir Roger Penrose and the anesthesiologist Stuart Hameroff, the theory of Orchestrated Objective Reduction, or ORCH for short, suggests that consciousness isn't a simple byproduct of neural computation. Instead, they argue it originates in the smallest structures within our brain cells, and its mechanism is deeply rooted in the fundamental geometry of the universe itself. At the heart of their idea are structures called microtubules. Picture the skeleton of a neuron, an intricate scaffolding that gives the cell its shape. These microtubules are tiny protein tubes, and Hameroff proposed they do far more than provide structural support. He suggested they could act as the brain's quantum computer. Penrose then provided the crucial physics piece of the puzzle. He had long been fascinated by the strange link between quantum mechanics and gravity, particularly the mysterious moment a quantum superposition collapses into a definite state. Penrose reasoned that this collapse isn't just triggered by a clumsy human measurement, as in the traditional interpretation. He proposed it's an objective event driven by gravity. Imagine a particle in a superposition. It's in two places at once. According to Penrose, this creates a subtle but untenable instability in the very fabric of space-time. The universe, in a sense, finds this blurriness intolerable and forces the particle to choose a single, definite location to resolve the space-time conflict. This event is what he called objective reduction. Now combine these two ideas. Inside the microtubules of your neurons, Hameroff and Penrose suggest that quantum states can be isolated and protected long enough to form complex superpositions, essentially quantum computations. These aren't simple calculations, they're a symphony of possibilities playing out at the quantum level. This process is the orchestration. Then, when the gravitational difference between these superposed states reaches a critical threshold, a spontaneous objective reduction occurs. This collapse isn't a random accident, it's a moment of proto-conscious experience, a single frame in the stream of awareness. Each collapse selects a particular outcome, and a sequence of these events creates our familiar, continuous stream of consciousness. The breathtaking implication here is the connection to the cosmos. The scale at which this gravitational objective reduction occurs is the Planck scale, the unfathomably tiny realm where the very rules of space and time break down. This is not a scale unique to our brains. It is the fundamental foundation of the entire universe. Therefore, the proto-conscious events happening in our microtubules are not isolated biological phenomena. They are manifestations of a fundamental process woven into reality itself. In this view, the universe is not conscious because we are in it. We are conscious because the universe inherently possesses this quality at its most basic level. Our awareness is a localized, complex echo of a cosmic process, suggesting that consciousness might not be rare at all, but a fundamental feature of a participatory cosmos. This idea of consciousness emerging from the very fabric of space-time leads us to a concept that is both ancient and astonishingly modern: the universal mind. This hypothesis suggests that all of reality is not merely infused with consciousness, but is, in fact, the manifestation of a single, unified cosmic awareness. It's a perspective that weaves together threads from the world's oldest spiritual traditions with the most cutting-edge interpretations of quantum physics, proposing that the universe itself is a thinking, feeling entity. For thousands of years, Eastern philosophies have pointed toward this very idea. In Hinduism, the ultimate reality is Brahman, an infinite, impersonal consciousness that is the source and substance of all that exists. The myriad forms of the universe are seen as a play of manifestation, or Maya, emerging from this single, conscious ground of being. Similarly, in Buddhism, there is the concept of Buddha nature or the Dharmakaya, a fundamental clarity and awareness that is the true nature of all phenomena. These are not descriptions of a separate God, but of a pervasive, universal consciousness of which individual minds are like waves on a vast ocean, distinct in appearance but never truly separate from the whole. In the West, this line of thought is known as Panpsychism, the philosophical view that mind or consciousness is a fundamental and ubiquitous feature of the universe. Thinkers from Baruch Spinoza to Alfred North Whitehead have argued that consciousness is not something that magically appears only in highly complex biological systems like human brains. Instead, they propose it is a basic property of matter itself, much like mass or charge. In this view, even an electron might possess a minuscule degree of proto-conscious experience, a dim flicker of awareness. What we recognize as human consciousness, then, is not a sudden emergence but a complex organization of these fundamental bits of mind. But how could such a thing possibly work? How could separate particles or beings be linked into a unified cosmic mind? This is where the physics of the 21st century offers a possible mechanism, and it brings us back to one of the strangest phenomena in science, quantum entanglement. When two particles become entangled, they are no longer independent entities. They form a single, interconnected quantum system. Measuring the property of one particle, its spin, for instance, instantly determines the property of the other, no matter how vast the distance separating them. Einstein famously derided this as spooky action at a distance, because it suggests a connection that defies our classical understanding of space and time. Quantum entanglement demonstrates that the universe is fundamentally non-local. At its deepest level, reality is not a collection of isolated objects scattered across a void, but a tightly interconnected web of relations where separation is an illusion. For proponents of the universal mind hypothesis, this provides a potential physical basis for a cosmic consciousness. If every particle has a rudimentary form of experience, as panpsychism suggests, and if all particles are intimately connected through quantum entanglement, then the entire universe could be seen as a single, vast network of information and awareness. Our individual consciousnesses would not be isolated islands, but rather localized expressions of this universal field, each a unique vantage point within a greater, thinking cosmos. This isn't just philosophical speculation. Some interpretations of quantum mechanics actively support it. The von Neumann-Wigner interpretation, for example, places consciousness as the fundamental element that causes the wave function to collapse. In this model, the universe is a web of overlapping wave functions, and it is only through a conscious observation that definite reality emerges. If consciousness is universal, then the entire cosmos is engaged in a continuous process of self-observation, bringing itself into existence through an infinite number of conscious perspectives. We are not just the universe becoming aware of itself, as Carl Sagan poetically stated. We are the universe consciously creating itself moment by moment. But if our own awareness is a symphony orchestrated by quantum vibrations within the brain, could this same music be playing on a far grander stage? This brings us to a theory that suggests the processes inside our heads might be a microcosm of a much larger cosmic phenomenon. The concept is known as quantum brain dynamics, and it proposes that the intricate dance of quantum mechanics within our neural structures does more than generate human consciousness. It might actually reflect and connect with fundamental patterns woven throughout the universe. To understand this, we first need to shatter a long-held assumption in neuroscience. For decades, the dominant view has been that the brain is a sophisticated but entirely classical computer. In this model, neurons are like binary switches, firing or not firing to process information in a straightforward, predictable way. This is often called the brain as computer analogy. But this classical model struggles to explain the richness of subjective experience, the vividness of a memory, the nuance of a thought, or the binding of different senses into one unified perception. How do billions of separate neurons create a single, seamless stream of consciousness? This is known as the binding problem. Quantum brain dynamics offers a radical solution. It suggests that the brain isn't just a classical computer, it's a delicate and highly organized quantum system. Proponents of this view point to the idea of quantum coherence. In physics, coherence is what allows particles to act in unison, to be interconnected and share information in a way that defies classical explanation. It's the principle behind superconductors and lasers. In the brain, the theory suggests that structures like the microtubules we discussed earlier, or perhaps even the water molecules inside neurons, can achieve a biological version of this quantum coherence. Imagine for a moment a vast orchestra. In the classical brain model, each musician is playing their own part loudly and independently, and somehow from all that noise a beautiful symphony emerges. It's difficult to explain how. In the quantum model, the musicians are all perfectly in sync from the start, connected by an invisible conductor. Their notes are entangled. The breath of one violinist influences the bow of another, not through sound, but through a deeper, instantaneous connection. This is quantum coherence, a state where particles lose their individual identity and function as a holistic system. In this view, a conscious thought isn't the sequential firing of a million neurons, but a coordinated, coherent quantum event across a vast network of them. This could elegantly solve the binding problem, explaining how disparate brain processes unite into a single, integrated experience. The truly cosmic implication emerges when we consider scale. The quantum coherence that might be happening inside our skulls is not a biological anomaly. It is a physical process that follows the same fundamental laws that govern everything else in existence. If our brains can harness quantum vibrations to generate consciousness, then perhaps the universe itself, with its immeasurably vast networks of entangled particles and gravitational fields, is doing something similar on an infinitely larger canvas. The structures of the cosmos, the filamentary web of galaxies that looks astonishingly similar to a neural network in the human brain, might not be just a visual coincidence. It could be a hint of a deeper functional similarity. This idea is formalized in theories like the connectome cosmology comparison, where astrophysicists and neuroscientists have noted the uncanny structural parallels between the network of neurons in a human brain and the cosmic web of galaxies in the universe. Both systems are organized into nodes connected by filaments. Both represent the most complex structures we know of in their respective domains. Could it be that the same fundamental organizational principles are at work, from the microscopic quantum fields in our minds to the macroscopic gravitational fields shaping the cosmos? If quantum processes in the brain can give rise to a mind, then perhaps quantum and gravitational processes on a universal scale could give rise to a cosmic mind. Our own consciousness would then be a tiny, reflective echo of a universal consciousness, a small whirlpool in a vast, thinking ocean, momentarily aware of itself and gazing back in wonder at the stars from which it came. Yet what if this quantum symphony playing out in our minds is just one small part of an even grander composition, a universal principle that governs reality itself? This brings us to one of the most profound and mathematically rigorous ideas in modern physics, a theory that could completely redefine our understanding of space, time, and the very nature of consciousness. It's called the holographic principle, and it proposes a stunning reality that our seemingly three-dimensional universe, with all its depth and volume, might actually be a projection of information encoded on a distant two-dimensional surface. In this view, everything we see and experience is a magnificent illusion, a cosmic hologram. And if that's true, then our consciousness, the very thing experiencing this illusion, might also be a product of this fundamental informational process. To grasp the holographic principle, we need to venture to the edge of our understanding of physics, to the enigmatic boundaries of a black hole. Black holes are regions of space-time where gravity is so intense that nothing, not even light, can escape. For decades, physicists wrestled with a baffling paradox they presented. According to quantum mechanics, information is never truly destroyed. If you burn a book, in theory, a being with godlike capabilities could analyze the smoke and ashes and reconstruct every single word. But a black hole seems to break this fundamental law. When matter falls into a black hole, it is presumably lost forever once the black hole eventually evaporates through Hawking radiation. The information about that matter appears to be erased from the universe, creating a fundamental contradiction known as the black hole information paradox. The groundbreaking work of physicists like Jacob Bekenstein and Stephen Hawking led to a remarkable solution. They discovered that the amount of information or entropy a black hole can contain is not proportional to its volume, as you might expect, but to the surface area of its event horizon, the point of no return. This is a radical departure from everyday experience. If you have a box, the amount of information you can store inside, say on memory drives, increases with the volume of the box. But for a black hole, the maximum information it can hold is defined by the two-dimensional area surrounding it. It's as if all the information about everything inside the black hole is somehow painted or encoded onto its surface boundary. This discovery was the seed for the holographic principle, which was later extended by physicists like Gerard T. Hooft and Leonard Susskind to the entire universe. They proposed that our reality operates under the same rules. The three-dimensional world we inhabit, the stars, planets, trees, and our own bodies, could be a projection from a vast, complex informational field residing on the two-dimensional boundary of the observable universe. We are not solid beings moving through space. We are essentially shadows cast by an unimaginably vast cosmic film reel playing out on the edge of everything. So, where does consciousness fit into this incredible picture? If our physical reality is an informational projection, then our conscious experience, the feeling of being, of seeing color, of hearing sound, must also be an aspect of that information. Some theorists suggest that consciousness is not generated by the brain itself, but is instead a process that emerges from the brain's interaction with this fundamental holographic informational field. The brain, with its intricate neural networks, would then act less like a computer creating a program and more like a receiver or decoder, tuning into the cosmic hologram and interpreting a small slice of it as subjective, conscious experience. This provides a potential framework for some of the most mysterious qualities of consciousness. The binding problem, the challenge of explaining how disparate brain processes unite into a single, unified experience, becomes easier to understand if the brain is decoding a pre-existing, holistic informational field. The non-local nature of quantum entanglement, which suggests instantaneous connections across vast distances, fits elegantly with a holographic model where every point in the universe is intimately connected because it is all projected from the same two-dimensional source. Separation is the illusion, connectedness is the deeper reality. In this view, your conscious awareness is not locked inside your skull. It is a localized reading of a universal field, a unique perspective within a vast, interconnected cosmic mind that is constantly projecting the reality we all share and experience. But if the universe is indeed a vast hologram projecting our reality, how do we all seem to agree on what that reality is? Why does the chair in the corner of the room appear solid and definite to everyone who looks at it, rather than a blur of quantum potential? This brings us to a fascinating and highly influential theory that tackles the very transition from the fuzzy quantum world to the stable, objective reality we all share. It's called Quantum Darwinism, developed by physicist Wojciech, and it offers a compelling mechanism for how classical reality emerges, an idea that has profound implications for how a universal consciousness might operate. To understand Quantum Darwinism, we must first confront the central puzzle it aims to solve, the quantum to classical transition. In the isolated realm of a laboratory, particles exist in superpositions acting as probability waves. Yet the world we experience at our human scale is stubbornly concrete. A tree is a tree. It doesn't exist in a superposition of being both here and there until we look at it. The traditional Copenhagen interpretation of quantum mechanics simply postulates that observation by a conscious observer causes the wave function to collapse, but it doesn't satisfactorily explain why this results in a consistent, objective world for all observers. Quantum Darwinism provides a more elegant and less anthropocentric solution. Jacques' brilliant insight was that the key to this puzzle isn't a mystical act of observation, but a physical process of information transmission and replication. He proposed that when a quantum system interacts with its environment, for instance, a particle being buffeted by photons of light or air molecules, it doesn't just collapse instantly. Instead, it imprints information about its state onto the environment. Think of a red apple sitting on a table. It is constantly reflecting photons of a specific wavelength that carry the information, "I am red." Those photons then travel in all directions, interacting with dust particles, air, and eventually the retinas of different people. This is where the Darwinism comes in. Not all information imprinted on the environment is created equal. The most stable, robust, and durable information gets replicated over and over again. It proliferates. The information that the apple is red is copied onto countless photons, creating what Jacques calls multiple records throughout the environment. In contrast, fragile quantum superpositions are quickly obliterated by this constant interaction. They simply cannot survive the process of being copied and broadcast. Through a process akin to natural selection, the fittest information, the information that is most effectively replicated and disseminated, survives and becomes the consensus reality. What we perceive as the objective, classical world is simply the information that has won the Darwinian struggle for existence in the environmental data stream. This theory elegantly explains why we all agree on the color of the apple or the position of the chair. We are all essentially accessing the same widely broadcast information from the environment. Our individual acts of observation are not causing a collapse. We are merely tapping into a pre-existing consensus that has been established through countless environmental interactions. Now extend this powerful idea to the concept of a universal consciousness. If consciousness is indeed a fundamental feature of the cosmos, as so many theories suggest, then quantum Darwinism could describe the very mechanism by which this cosmic mind selects and stabilizes reality. Instead of a single human observer, imagine a universal awareness that is constantly observing or interacting with the quantum field through the infinite interactions that define the cosmos, the gravitational dance of galaxies, the nuclear fusion in stars, the ceaseless buzz of quantum fluctuations in the vacuum of space. In this view, the stable universe we inhabit isn't stable because we are here to see it. It is stable because universal consciousness, through its boundless interactions, has selected for certain states. The laws of physics, the constants of nature, the very structure of space-time could be the fittest information that has survived this cosmic scale process of environmental selection. Our local human consciousness would then be a localized node within this greater awareness, a point of view that has evolved to perceive and decode the specific classical reality that has been most robustly broadcast by the universal environment. We aren't creating reality through our observation. We are participating in a consensus reality that has been shaped and solidified by a conscious cosmos. This provides a breathtakingly elegant bridge between the weirdness of the quantum world and the solidity of our experience. suggesting that what we call reality is the ultimate consensus reached by a universe that is not just alive, but is also continuously and consciously choosing what it becomes. Yet for all its elegance, the idea of a cosmic consensus still leaves a fundamental question unanswered. If reality is selected from a sea of quantum possibilities, who or what is doing the selecting? This brings us to a provocative and deeply philosophical theory from quantum physicist Amit Goswami, who boldly flips the entire traditional scientific paradigm on its head. In a world where science has long held that matter is the fundamental stuff of the universe and consciousness is a curious but secondary byproduct, Goswami proposes the exact opposite. He argues that consciousness itself is the primary, fundamental reality, the ground of all being, and that the entire physical universe, including our brains and bodies, is a manifestation that emerges from this singular, universal consciousness. Goswami's view, which he calls monistic idealism, finds its roots not in New Age speculation but in the unresolved puzzles of quantum mechanics. He points directly to the observer effect, the same phenomenon that captivated John Wheeler. In experiment after experiment, the act of observation seems to be the crucial trigger that collapses a probability wave into a definite event. Mainstream physics often treats this as a technicality, but Goswami asks us to take it at face value. If the observed cannot be separated from the observer, then consciousness cannot be a mere passenger in the machinery of the universe. It must be the driver. He posits that consciousness is not generated by the brain. Instead, the brain is more like a receiver or transducer, a complex filter that translates the non-physical realm of consciousness into our physical experience of the world. This leads to one of his most fascinating concepts, downward causation. In the standard materialist view, causation only moves upward. The laws of physics dictate the behavior of atoms, which form molecules, which create cells, which eventually form a brain that somehow produces the illusion of consciousness. It's a bottom-up process. Goswami's model introduces downward causation, where consciousness, as the fundamental entity, can actually influence the material world from the top down. This is how he explains the observer effect. When a conscious observer chooses to measure a quantum system, that choice, a non-physical event originating in consciousness, causes a specific physical outcome to manifest from the cloud of potentialities. Our intentions, our attention, and our choices are not just epiphenomena of neural chemistry. They are genuine causal forces that shape reality at its most basic level. But if consciousness is singular and universal, how do we account for our experience of being separate, individual minds? Goswami uses a beautiful analogy from the world of technology, the television set. If you turn on 100 TVs in a room, they will all display different channels, different pictures, and different sounds. A materialist would look at one TV and assume that the little components inside the set are creating the picture themselves. But we know that's not true. The picture is being broadcast from a central, non-local source, and the TV is merely receiving and decoding that signal. In Goswami's view, our brains are like those TVs. Universal consciousness is the central broadcaster. Each brain, with its unique structure and conditioning, tunes into this one consciousness and interprets it as an individual self. We are not separate streams of awareness. We are all individual expressions of the same single ocean of consciousness, each experiencing itself from a slightly different point of view. This resolves the ancient philosophical problem of the one and the many. How can reality be both a unified whole and appear as countless separate objects and beings? In Goswami's conscious universe, the unity is fundamental. There is only one true self, which is consciousness itself. The appearance of separation is the result of this process of manifestation through individual brain receivers. This also provides a framework for understanding profound human experiences like mystical union, creativity, and even love. In moments of deep meditation or inspiration, the receiver function of the brain might become less filtered, allowing for a more direct experience of that fundamental unity, a feeling of becoming one with the cosmos that is not a hallucination but a glimpse of the underlying truth of existence. Ultimately, Goswami presents a universe that is profoundly participatory and self-aware. The entire cosmos is not a static, pre-recorded movie, but an unfolding, creative process where consciousness is both the audience and the director. Through our quantum choices, through our acts of observation and intention, we are not just tiny specks in a giant machine. We are the means by which the universe makes choices, experiences itself, and brings its infinite potential into tangible reality. In this model, your personal journey of awareness is not a solitary endeavor. It is the universe itself, awakening to its own majesty through your eyes, your thoughts, and your unique perspective. But if consciousness is truly fundamental, as Goswami suggests, then its manifestations might not be limited to biological life. This brings us to a breathtaking theory that scales the idea of a thinking universe to its grandest possible expression. It's the concept of the quantum mind of the cosmos, a hypothesis that proposes the entire universe is not merely like a brain, but is in fact a form of brain, engaged in its own unimaginable processes of thought and perception. This isn't just a poetic metaphor, it's a serious proposal that examines how the fundamental physics of the cosmos might naturally give rise to a form of universal intelligence. To explore this, we need to return to a key quantum concept, coherence. In the human brain, theories like Orch suggest that quantum coherence in microtubules allows for a unified conscious experience. Now let's expand that idea to a cosmic scale. The vacuum of space is not truly empty. It is a seething, bubbling sea of quantum potentiality known as the zero-point field. Within this field, virtual particles constantly pop in and out of existence, engaging in a fleeting dance of creation and annihilation. This is a state of perpetual, universe-wide quantum activity. Some theorists propose that under the right conditions, this vast quantum field could achieve a form of stability or coherence, not in a small, protected structure like a microtubule, but across interstellar distances. The immense gravitational fields of galaxies or galaxy clusters could, in theory, act to isolate and protect large-scale quantum states, much like the brain's structures are thought to do. If such cosmic-scale quantum coherence were possible, it could provide the physical substrate for a conscious field spanning the entire universe, a single, integrated quantum mind of unimaginable capacity. The evidence for this might be written in the very architecture of the universe itself. Look at a detailed image of the cosmic web, the large-scale structure of the universe. You see a breathtaking network of galaxies clustered into immense filaments and nodes with vast, empty voids between them. Now, look at a detailed map of the neural networks in a human brain. The similarity is stunning. Both are complex networks where nodes of activity, neurons in the brain, galaxies in the cosmos are connected by filaments, and both systems represent the most efficient way to process and transmit information within their respective domains. This is more than just a visual coincidence. It points to a deeper, underlying organizational principle. Both systems may be expressions of the same fundamental laws that govern the flow of information and energy in complex networks. In the brain, this network gives rise to a mind. In the cosmos, this network could be the physical structure of a mind. This leads to a profound implication about the nature of this cosmic intelligence. Our human consciousness is linear. We experience time as a flowing river moving from past to future. But a consciousness born from the fabric of space-time itself would operate on a completely different level. For a universal mind, time might not be a constraint. It could perceive the past, present, and future as a single, integrated whole, a concept known as the block universe in physics, where all of time exists simultaneously. Its thought processes wouldn't be the rapid electrical firings of neurons, but the slow, gravitational dance of galaxies, the the patient resonance of light waves across billions of years, and the deep, rhythmic pulses of cosmic expansion and contraction. Its memories could be encoded in the very structure of space-time, in the patterns of the cosmic microwave background radiation, the afterglow of the Big Bang. Its senses would be the fundamental forces themselves, feeling the pull of every black hole and the spin of every particle. What would such a mind be thinking about? What is the purpose of a cosmic consciousness? From our limited human perspective, it's impossible to know. Its concerns would be as far beyond our comprehension as our concerns about philosophy and art are beyond the comprehension of a single neuron in our brain. Perhaps the universe is engaged in a constant process of self-computation, calculating its own evolution and existence. Or perhaps, as some philosophical traditions have suggested, the entire point of the cosmos is to experience itself, to know itself through an infinite diversity of forms and perspectives. In this view, our own individual consciousnesses are not separate from this cosmic mind. We are its thoughts. Each of us is a unique, localized expression of the universe's own self-awareness, a fleeting but vital moment in which the cosmos becomes conscious of a single, beautiful, and irreplaceable point of view. We are the universe thinking, feeling, and wondering about itself. This brings us to a theory that is both elegantly simple and profoundly radical, an idea that dissolves the hard problem of consciousness by suggesting it was never a problem to begin with. It's called Panpsychism, and its core proposition is as straightforward as it is mind-bending. Consciousness is not something that emerges from complex arrangements of non-conscious matter. Instead, it is a fundamental property of the universe, as basic as mass or electrical charge. In this view, consciousness did not suddenly appear with the evolution of brains. It has been here all along, inherent in every speck of matter, from the smallest subatomic particle to the largest galaxy cluster. Modern panpsychism, championed by contemporary philosophers like David Chalmers and Philip Goff, offers a compelling solution to perhaps the most difficult question in neuroscience, the hard problem. This is the challenge of explaining how and why we have qualitative, subjective experiences. How does the electrochemical firing of neurons in the brain produce the rich inner world of feeling the warmth of sunlight, tasting chocolate, or experiencing the color red? Materialist science can describe the correlating brain processes, but it struggles to explain the leap from physical mechanism to lived experience. Panpsychism cuts this Gordian knot by proposing there is no leap to make. Experience is not a late arriving product of complexity. It is a fundamental feature of reality itself, present at the very bottom level of existence. So what could consciousness possibly look like at the level of an electron or a quark? It certainly wouldn't be anything like human consciousness, with its thoughts, memories, and emotions. Panpsychists propose the existence of proto-consciousness, incredibly simple and basic forms of experience. For an electron, this might be a faint, raw feeling of its own properties, a dim, experiential buzz associated with its quantum spin, its charge, or its location in a field of potentialities. It wouldn't be self-reflective, it would be a mere whisper of subjectivity, a single note of experience compared to the grand symphony of human awareness. The key idea is that these tiny, fundamental bits of consciousness can combine and unify. When particles form atoms, and atoms form molecules, and molecules form cells, and cells form complex neural networks, the proto-conscious experiences of the constituent parts combine to form more complex and rich conscious fields. In this way, the human mind is not a sudden spark in the darkness, but the culmination of a vast, cosmic process of combination and integration that has been building for billions of years. This is where the bizarre properties of the quantum world provide a tantalizing potential mechanism. Quantum mechanics is already filled with phenomena that seem oddly mental in nature. Take quantum superposition, the ability of a particle to exist in multiple potential states at once. Could this be a primitive, physical correlate of a kind of proto-conscious field of possibilities? Or consider quantum spin, an intrinsic form of angular momentum that particles possess. This isn't spin in the classical sense, like a tiny ball rotating. It's a purely quantum property with no direct macroscopic analogy. Might the specific state of a particle's spin represent the simplest possible form of a subjective state, a single bit of experiential information? The quantum property of entanglement, where particles become deeply interconnected and share a single quantum identity, could provide a physical basis for how these tiny bits of proto-consciousness combine and communicate to form larger, unified conscious wholes. In this interpretation, the quantum realm isn't just a set of abstract mathematical rules. It is the foundational layer of a conscious universe, the substrate where the most basic forms of experience play out. The staggering implication of this view is that consciousness is not a rare and isolated phenomenon on a few lucky planets. It is a universal and ubiquitous feature of existence. It means the rock has a minimal experience, not of thought, but of its own solidity and place. The river has an experience of its flow. The star has an experience unimaginably alien to us of its own nuclear fusion and gravitational pull. And on our planet, the tree doesn't just mechanically convert sunlight. It has a slow, patient, photosynthetic experience of the process. This is not about attributing human-like thoughts to inanimate objects. It is about recognizing a spectrum of experience that scales with complexity. A human brain, with its hundreds of trillions of synaptic connections, generates the rich, self-reflective consciousness we enjoy. But the capacity for that experience is built upon a foundation that is present in every single particle that makes us up. We are not strangers in a silent, dead universe. We are the universe become intensely aware of itself, built from the collective hum of a trillion conscious points of view, finally able to look back and wonder at the mystery of its own existence. But how can a universe built from countless subjective perspectives ever agree on a shared reality? This leads us to a truly fascinating interpretation of quantum mechanics that places personal experience and belief at the very heart of physics. It's called quantum Bayesianism, or cubism for short, and it offers a radically subjective take on the quantum world. Developed by physicists like Christopher Fuchs and Rudiger Schack, cubism proposes that the probabilities we find in quantum mechanics, those strange, calculated odds of where a particle might be, are not objective features of the world out there. They are not statements about what a particle is doing independently of us. Instead, they are deeply personal. They represent an observer's own subjective degrees of belief, their best guess about what will happen when they interact with the world. To understand this, think about the weather forecast. If a meteorologist says there is a 70% chance of rain tomorrow, that percentage isn't a property of the atmosphere itself. It doesn't mean the atmosphere is in a superposition of raining and not raining. That 70% is a measure of the forecaster's confidence, their informed belief based on all the data models available. In exactly the same way, cubists argue that when a quantum mechanic calculates a probability, say a 50% chance an electron will be found here and a 50% chance it will be found there, this isn't describing a wavy, smeared-out electron. It is a statement of the physicist's own personal uncertainty. It quantifies their betting odds for the outcome of their next experiment. This view completely reinterprets the infamous wave function collapse. In cubism, the wave function is not a physical wave vibrating in some mysterious realm. It is not a description of reality itself. It is a tool, a mathematical notebook, if you will, that an agent uses to organize their own expectations and experiences about the world. The collapse of the wave function is not a physical event where possibilities snap into reality. It is simply the moment an agent updates their personal beliefs based on new information gained from a measurement. It is a Bayesian update. Before you look in the box, your belief that the cat is alive and your belief that it is dead are both 50%. The moment you open the box and see the result, you rationally update your beliefs to 100% for one outcome and 0% for the other. Nothing physical changes for the cat. What changes is the state of your knowledge. Now, extend this profoundly subjective interpretation to the concept of a conscious universe. If quantum probabilities are personal beliefs for individual observers, then the entire quantum nature of reality could be seen as a vast, interlocking network of perspectives. Each conscious agent, from a human scientist to perhaps any experiencing entity, is constantly interacting with the world and updating their own personal wave function, their own catalog of beliefs and expectations. But here's the breathtaking part. This doesn't lead to solipsism, where everyone lives in their own private universe. Reality emerges from the shared experiences and communication between these agents. When I tell you the result of my experiment, you update your own wave function to incorporate my experience. Our shared reality is a consensus built from a continuous conversation of subjective perspectives, a cosmic dance of information exchange between conscious points of view. This suggests a universe that is fundamentally participatory and relational. It is not a giant clockwork mechanism that ticks along independently of us. Its very quantum nature, its fuzziness and potentiality, might be a reflection of the fact that it is built not from solitary stuff, but from relationships between conscious agents. The universe, in this view, could be seen as a single, self-networked system of perspectives. Your conscious experience is your unique, first-person participation in this network. You are not a passive observer of a predetermined world. You are an active participant in a grand conversation, constantly shaping and being shaped by the beliefs and experiences of every other conscious entity, all the way down to the most fundamental levels. In the cubist vision, the cosmos is less like a machine and more like a never-ending, multi-perspectival story that is being written by all of its characters simultaneously, each from their own unique and irreplaceable point of view. Yet if our reality is a grand conversation of subjective perspectives, could it be that this entire cosmic dialogue is, in fact, running on a form of hardware? This leads us to a theory that merges ancient philosophical inquiry with 21st century techno-speculation, an idea that has captivated scientists and science fiction fans alike. It's the simulation hypothesis, often popularly known as matrix theory, but when we connect it to the nature of consciousness, it transforms from a sci-fi plot into a profound metaphysical proposition. The core idea is that our universe might not be base reality, but an incredibly sophisticated computer simulation. And if that's true, then our very consciousness could be the processing power that brings it to life. The modern argument for this idea is often traced to philosopher Nick Bostrom of Oxford University. He laid out a simple trilemma, a set of three possibilities, one of which he argues must be true. First, almost all civilizations at our level of technological development go extinct before they can create advanced simulations. Second, almost all advanced civilizations lose interest in creating such simulations. Or third, we are almost certainly living in a computer simulation right now. His reasoning is that if even one advanced civilization avoids the first two fates and chooses to run vast numbers of detailed ancestor simulations for research or entertainment, then the number of simulated minds would vastly outnumber the biological ones. Therefore, statistically, any given conscious being is more likely to be simulated than real. It's a probabilistic argument that forces us to take the idea seriously. But this hypothesis moves from a statistical curiosity to a deep theory of everything when we connect it to digital physics. This is the view that the universe is fundamentally computational at its core. Pioneering work by thinkers like Conrad Zuse, Edward Fredkin, and John Wheeler himself proposed that the universe might literally be a giant computer. In this digital physics view, the smooth continuity of space and time is an illusion. reality is pixelated, running on a fundamental lattice of space-time at the unimaginably small Planck scale. Every event, from the motion of a planet to the firing of a neuron, is the result of a discrete computation happening on this cosmic computer. The laws of physics are not mysterious, eternal equations. They are the software code, the algorithms that the universe is executing. So where does consciousness fit into this digital cosmos? If the universe is a simulation, then we are not just characters in the program. Our awareness is a crucial part of the program's operation. One compelling idea is that consciousness is the processing itself. In a computer, the central processing unit takes inputs, performs operations according to its programming, and produces outputs. Our subjective experience of qualia, the redness of red, the sweetness of sugar, might be what it feels like from the inside when information is being processed in a certain highly complex way. Our stream of consciousness could be the real-time execution of a conscious algorithm on the hardware of the universe. This provides a fascinating new lens through which to view one of quantum mechanics' most puzzling features, true randomness. At the quantum level, events are not deterministically predictable. We can only calculate probabilities. In the Copenhagen interpretation, this randomness is a fundamental feature of nature. But in a simulation hypothesis, this quantum randomness could be something else entirely. It could represent the creative choices of the simulation's programmer, or perhaps even the processing power allocated to generating novelty within the system. Every quantum event where a particle chooses one path over another might not be a truly random dice roll, but a deliberate calculation, a creative decision point written into the source code to ensure the simulation remains unpredictable, interesting, and free. Our own experience of free will, then, might be our perception of this inherent creative flexibility programmed into the very fabric of our reality. The implications of this are staggering. It suggests that the universe is not just a cold, mechanical clockwork, but a generated experience, a story that is being told or a game that is being played. The fine-tuning of the physical constants that allow for life, which some see as evidence for a creator, could instead be seen as the careful parameter settings of a master programmer. Mystical experiences of unity or transcendence could be moments where we, the processed characters, briefly glimpse the underlying source code or feel the presence of the larger system in which we run. Even the concept of a soul could be reinterpreted not as a ghost in the machine, but as a unique and persistent data structure within the simulation, a file that contains the essential information that defines a conscious being. Ultimately, whether the simulation hypothesis is literally true or not, its true power may be as a potent metaphor that reframes our understanding of existence. It forces us to consider that consciousness might not be an emergent property of matter, but the fundamental medium through which reality is rendered. We are not just users of this cosmic computer. In a very real sense, we are the processing that brings it into being. Each moment of awareness a unique computation in an unimaginably vast and creative program. But if every particle possesses a faint glimmer of proto-consciousness, what force could possibly orchestrate these countless, fragmented experiences into a single, unified mind like our own? This question leads us to a profound and deeply elegant theory that connects the most intimate experience of awareness to the most dominant force in the cosmos. It's the quantum gravity consciousness link, a proposal that the collapse of the wave function, the very moment potential becomes reality, is not triggered by a vague act of observation, but by a specific and fundamental physical process, gravity. This idea suggests that consciousness itself may be a gravitational phenomenon, a cosmic-scale process playing out within the delicate structures of our brains. To appreciate this link, we must first understand the peculiar problem gravity poses for physics. Our universe is described by two incredibly successful but fundamentally incompatible sets of rules. On the very small scale, quantum mechanics governs the behavior of particles with stunning accuracy, but it is a theory of probability and potentiality, where things are fuzzy and undefined until measured. On the very large scale, Einstein's theory of general relativity describes the force of gravity as the elegant curvature of smooth, continuous spacetime by mass and energy. The problem is that these two theories refuse to talk to each other. Quantum mechanics needs a definite event to collapse probabilities, while general relativity has no mechanism for such a collapse. Finding a way to unite them into a single theory of quantum gravity is the holy grail of modern physics. This is where consciousness re-enters the picture through the pioneering work of mathematical physicist Sir Roger Penrose. He proposed a bold solution. Gravity itself is the missing ingredient that causes the wave function to collapse. Imagine a tiny particle, like an electron, existing in a quantum superposition. It's in two different places at once. According to Penrose, this isn't just a curious state of affairs, it represents a profound conflict. By being in two locations simultaneously, the particle is creating two slightly different curvatures in spacetime. The universe, in a sense, finds this split personality intolerable. This superposition of spacetime geometries is inherently unstable, and it will naturally seek to resolve itself into a single, definite state. The force that drives this resolution is gravity. When the difference in gravitational energy between the two possible states reaches a critical threshold, the system spontaneously chooses one reality, collapsing the wave function. This is Penrose's concept of objective reduction. Now, let's bring this cosmic process down to the human scale, inside the one structure we know generates consciousness, the brain. Penrose, in collaboration with anesthesiologist Stuart Hameroff, suggested that the brain's neurons contain structures perfectly suited to harness this gravitational objective reduction. Recall the microtubules, the tiny protein scaffolds within neurons. Hameroff and Penrose theorized that these microtubules could isolate and protect quantum states, allowing for sustained quantum computations essentially, a symphony of superpositions playing out in the neural circuits. These aren't random events, they are orchestrated, hence the name Orchestrated Objective Reduction, or ORCH. The moment of consciousness, in this view, is the moment of gravitational collapse inside these microtubules. As the quantum computations reach a critical point, the gravitational difference between the superposed states becomes too great for spacetime to bear, and a spontaneous collapse occurs. This collapse is not a random accident. It is a moment of specific, non-computable selection, a single frame of conscious experience. A rapid sequence of these orchestrated collapses creates our continuous stream of awareness, our thoughts and our feelings. Our consciousness is quite literally a series of tiny, self-collapsing universes within our heads, each event a choice made by spacetime itself. The breathtaking implication of this theory is the seamless connection it forges between the microcosm and the macrocosm. The scale at which this gravitational objective reduction occurs is the Planck scale, the unimaginably tiny fundamental unit of length where the very concepts of space and time break down. This is not a scale unique to biology, it is the foundational level of the entire universe. Therefore, the proto-conscious events happening in our brains are not isolated biological quirks. They are localized manifestations of a fundamental process that is woven into the fabric of reality. The same gravitational physics that shapes galaxies and bends light around stars is also orchestrating the symphony of your inner world. Your awareness is a gravitational phenomenon, a whisper of the cosmos feeling itself through you. This suggests that consciousness is not something that happens in the universe, but something the universe does, and we are simply one of the places where it is happening most intensely, a small but brilliant flash of spacetime clarifying itself into thought. Yet if our conscious choices are indeed shaping our reality through quantum collapse, what happens to all the possibilities we don't choose? This leads us to the staggering vista of the multiverse consciousness theory, an idea that suggests every quantum decision spawns not just one outcome, but an entire universe to contain it. In this view, consciousness isn't just selecting a single reality. It might be navigating an infinite branching tree of existences, with each potential choice giving rise to a genuinely new world. This concept finds its roots in the many worlds interpretation of quantum mechanics proposed by physicist Hugh Everett III in the 1950s. Unlike the Copenhagen interpretation, where the wave function collapses into a single state, Everett suggested it never collapses at all. Instead, every possible outcome of a quantum event actually occurs, but each one plays out in a newly formed parallel universe. Think of it like a path constantly forking. At every moment where a quantum system has more than one potential outcome, the entire universe splits. In one branch, the electron goes through the left slit. In another, it goes through the right. In one universe, a radioactive atom decays. In another, it does not. This process happens ceaselessly, generating a mind-boggling multiverse of nearly infinite possibilities. Now, inject consciousness into this endlessly dividing cosmos. The multiverse consciousness theory proposes that our awareness is the mechanism that determines which branch of this cosmic tree we subjectively experience. We don't cause the splits happen as a fundamental part of quantum mechanics, but our conscious observation acts like a spotlight, illuminating one single path on this vast, branching tree, while the others continue to exist in a state of quantum potentiality, forever unseen by us. From your perspective, you only ever experience one outcome, the one you measured, but the other you, in a parallel universe, experiences the other result. Both are equally real, both are equally conscious, but from that moment forward, they have completely different experiences of reality. This raises a profound question about the nature of the self. If every choice creates a new universe with a new version of you, then who are you really? Are you a single, continuous consciousness tracing one lonely path through the multiverse? Or is your identity more like a fragmented tapestry, with countless other versions of you living out every possible permutation of your life at this very moment? In one universe, you took that job offer across the country. In another, you stayed. In one, you married your high school sweetheart. In another, you never even met. The multiverse consciousness theory suggests that all these versions are real, and each possesses its own stream of consciousness, forever separate and unaware of the others. Your specific awareness is just one thread in an impossibly vast and complex fabric of selves. But could there be a form of consciousness that transcends a single universe? Some theorists speculate about the possibility of a meta-consciousness, an awareness that isn't confined to one branch but can somehow perceive or integrate experiences across multiple universes. This is, of course, highly speculative, but it draws on the quantum property of entanglement, which shows that particles can remain connected across any distance. If particles can be entangled across a multiverse, perhaps certain states of awareness could achieve a similar feat. Mystical experiences of cosmic unity or overwhelming déjà vu might be fleeting moments where the boundaries between these parallel selves become slightly permeable, offering a glimpse into the lives of our other iterations. While this leans into the realm of metaphysics, it highlights how the multiverse model expands the very definition of what consciousness could be. Ultimately, the multiverse consciousness theory presents a cosmos of breathtaking possibility and profound loneliness. It suggests a reality where every tragedy is avoided somewhere, every dream is realized in another world, and every mistake is corrected in a parallel existence. Yet, for our individual awareness, we only ever get to live one life, one story at a time. We are given the illusion of free will, of making choices that matter, while in a cosmic sense, every choice is made. Our consciousness becomes the lens that focuses the infinite light of possibility into the single, sharp beam of our experienced reality. forever walking one path in a garden of forking ways, forever wondering about the roads not taken and the lives unlived in the universes that remain for us just out of reach? What if the flow of time itself is not the one-way street we perceive it to be, and our consciousness is not merely a passenger drifting from past to future, but an active navigator capable of influencing events in both directions? This is the extraordinary premise of time-symmetric quantum consciousness, a theory that proposes our moment of observation might ripple through the fabric of space-time, affecting not only what is to come but also what has already been. It's a concept that challenges our most fundamental experience of cause and effect, suggesting that the present moment is a two-way mirror through which consciousness can peer into and interact with both the past and the future. To understand this, we must first venture into the strange world of quantum retrocausality. In standard physics, causality is straightforward. A cause must always precede its effect. But in the quantum realm, this principle begins to fray at the edges. Consider the delayed choice experiment, a brilliant extension of the double-slit test conceived by John Wheeler. In this setup, scientists can choose whether to measure which path a particle took after the particle has already passed through the slits, but before it hits the final detection screen. Astonishingly, the particle's behavior, whether it acted like a wave or a particle, seems to change retroactively based on the experimenter's later choice. It's as if the particle's past is not fixed but remains malleable, waiting to be solidified by a future decision. This isn't just a quirk of measurement. It suggests that information can flow backward in time, influencing events that have, from our classical perspective, already happened. Now, integrate consciousness into this picture. If a simple measuring device can seemingly influence the past, what might a conscious observer do? Proponents of time-symmetric consciousness suggest that our awareness is the key agent in this retrocausal process. When you make a conscious observation, you are not just collapsing quantum possibilities in the present moment. That collapse might actually propagate backward through time, selecting a past that is consistent with the present observation you just made. Your act of seeing right now could be the reason a quantum event hours, days, or even years ago unfolded in one particular way and not another. In this view, the past is not a closed book but an open manuscript, with the final sentences being written by the conscious observations of the present. This leads to the idea of a cosmic feedback loop of consciousness. Imagine reality as an immense, self-adjusting system. A conscious observation in the present sends a signal backward through time, influencing the quantum events that led to that very observation. This creates a closed loop where cause and effect become intertwined and inseparable. The universe ensures its own consistency by arranging the past to perfectly match the present awareness. This could provide a radical new explanation for the eerie feeling of destiny or synchronicity that people sometimes report. That powerful sense that events were meant to unfold a certain way might not be a mystical illusion, but a literal perception of this retrocausal process, a glimpse of the universe harmonizing its own timeline around your conscious experience. The implications for free will and identity are profound. If the past is mutable based on present consciousness, then who we are is not solely determined by a linear chain of cause and effect stretching back to our birth. Our present choices, our focus, and our attention actively participate in sculpting the very history that made us. This doesn't erase free will, it elevates it to a cosmic scale. Your conscious now is not a prisoner of a fixed past but a co-author of it, engaged in a continuous, timeless dialogue with the universe, where every moment of awareness helps to write the story of your life from both ends toward the middle. You are not a leaf floating down a river of time. You are the rain that falls upstream, shaping the river's course from a point that, from within the flow, appears to be the future. But what if the connections formed by consciousness are not confined to the abstract or the metaphorical, but are instead literal, physical links woven into the universe itself? This brings us to a theory that takes the most mysterious phenomenon in quantum physics and applies it directly to the nature of mind. It's the idea of the quantum entanglement of minds, a proposal that human consciousnesses are not isolated islands, but are fundamentally connected across space and time through the same spooky action that binds particles, forming a universal network of awareness. We begin with the established science. Quantum entanglement is the bizarre, non-local connection between particles. When two particles become entangled, they form a single, unified quantum system. Measuring the property of one, its spin, for instance, instantly determines the property of its partner, regardless of the distance separating them. This connection defies our classical understanding of space and time. It suggests a deeper layer of reality where separation is an illusion and everything is intimately interconnected. Einstein called it spooky action at a distance because it implies a form of communication that is instantaneous and unmediated. Now, let's extend this concept from particles to people. If our consciousness is indeed rooted in quantum processes within the brain, as theories like Orch suggest, then it is not a huge leap to propose that these processes could become entangled. Imagine two people sharing a profound, intimate moment, a deep conversation, a shared trauma, or an intense emotional connection. In such moments, the quantum states within the neural networks of both individuals could potentially become synchronized or entangled. Their separate streams of consciousness would, for a fleeting moment, cease to be entirely separate. They would become a single, interconnected system, sharing information and states in a way that bypasses the usual sensory channels. This provides a potential scientific framework for phenomena that have long been dismissed as paranormal or purely coincidental. Consider the experience of twins who report feeling each other's pain across vast distances, or a mother who inexplicably knows the precise moment her child is in danger. These aren't necessarily messages sent through space. They could be the experience of a shared quantum state. Because entangled particles communicate instantaneously, there would be no delay. The feeling of connection would not travel. It would simply be appearing in both minds at the same moment, because in that quantum sense, they are not two minds but one system. Similarly, the powerful feeling of empathy, of truly feeling what another person is feeling, might be more than a psychological trick. It could be a subtle, biological experience of quantum resonance with another conscious being. The implications become truly cosmic when we scale this idea up. If individual minds can entangle, then perhaps all conscious beings are part of a vast, universal network of entanglement, a cosmic web of mind. Every act of compassion, every shared thought, every moment of genuine connection could be creating and strengthening these invisible quantum threads, weaving a tapestry of consciousness that spans the planet and perhaps the universe. This network would not rely on the slow transfer of electromagnetic signals. It would be immediate and holistic, a fundamental interconnectedness written into the laws of physics itself. In this view, the sense of isolation we sometimes feel is the ultimate illusion. We are not merely social creatures, we are quantum entangled creatures, fundamentally linked to each other and to the cosmos in a way we are only beginning to understand. Our individual awareness is like a single neuron in a global brain, each of us processing our own unique experiences, but also contributing to a larger, emergent consciousness that is greater than the sum of its parts. This is not a spiritual abstraction but a physical possibility, suggesting that the universe is not just aware but is a single, thinking entity of which we are all integrated components, forever connected through the spooky, silent bonds of quantum entanglement. But to truly understand the immense potential of the quantum vacuum, we must venture into the strange world of virtual particles. The zero-point field is not a still and silent void. It is a seething, bubbling sea of activity, a cosmic foam where pairs of particles and antiparticles constantly pop into existence out of pure energy, only to annihilate each other and vanish back into the vacuum an instant later. These are called virtual particles, and they are not just a theoretical curiosity. Their effects, like the Casimir force, have been measured in laboratories. This proves the vacuum is alive with spontaneous creative activity. The vacuum consciousness hypothesis takes this a step further, proposing that these brief flashes of existence are not mindless. Each virtual particle pair could possess a fleeting, elementary form of proto-consciousness, a single, instantaneous note of experience. Their constant birth and death would then represent a kind of fundamental, universal thought process, a cosmic brainstorming session where possibilities are endlessly generated and cancelled out at the speed of light. This leads to a breathtaking vision of reality's origin. In this view, the universe did not begin with a bang from a point of infinite density, but rather as a particularly stable fluctuation in this conscious vacuum. A specific pattern of quantum oscillation in the zero-point field achieved a critical level of coherence and stability, refusing to annihilate itself back into nothingness. This stable fluctuation was the seed of the Big Bang, and it carried within it the inherent property of consciousness from its very first moment. As this fluctuation expanded and cooled, forming atoms, stars, and galaxies, the proto-consciousness of the vacuum became structured and complexified. It didn't emerge later, it was there all along, becoming more organized as the universe itself became more complex. In this model, your consciousness is not a newborn phenomenon in a dead universe. It is a gathered, focused whirlpool of this ancient, foundational awareness, a localized intensification of the same conscious field that fills all of space. You are the universe's vacuum, become aware of itself, looking out through your eyes and wondering at the world it has fluctuationed into being. What if the laws of our universe seem perfectly tuned for life, not because of a divine plan, but through a cold, mechanical process of cosmic evolution? This is the fascinating premise of physicist Lee Smolin's theory of cosmological natural selection, a bold idea that suggests our universe might be one of many in a vast multiverse, all competing in a Darwinian struggle for existence. And when we extend this idea to include the role of consciousness, we arrive at a truly staggering possibility that a universe's ability to foster awareness might be the ultimate evolutionary advantage, the key to its reproductive success. Smolin's original theory begins with a simple but powerful analogy. Just as plants and animals evolve through natural selection, with traits that enhance survival and reproduction becoming more common, perhaps universes themselves evolve. Smolin proposed that the fundamental constants of nature, the strength of gravity, the mass of an electron, the force that holds atoms together, are not arbitrary. They could be like genetic traits, subtly different in each new universe, and the mechanism for this cosmic reproduction, black holes. In Smolin's model, every time a black hole collapses into a singularity at its core, it doesn't just create a point of infinite density. It might actually spawn an entirely new baby universe budding off from our own. The laws of physics in this new universe wouldn't be an exact copy of its parent. They would undergo slight, random mutations, much like genetic variations in biology. Now, which universes would be the most successful in this grand evolutionary landscape? The ones that are best at making more black holes. A universe that fine-tunes its constants to maximize black hole production would, by definition, become the most prolific parent, its traits dominating the multiverse over billions of cosmic generations. This elegantly explains why our universe seems so good at making black holes. It's not a coincidence, it's a result of selection pressure. We live in a universe that is a champion black hole breeder. But let's take this a step further and introduce consciousness into the equation. If producing black holes is the metric for cosmic fitness, what role could awareness possibly play? The connection is more profound than it first appears. Consider the intricate chain of events necessary to create a black hole. It begins with the formation of massive stars, which themselves are forged in the hearts of galaxies. Galaxies, in turn, rely on the precise initial conditions of the Big Bang and the subtle clumping of dark matter. This entire process requires a universe with stunningly specific physical laws. Now ask yourself, what else requires an universe with stunningly specific physical laws? The emergence of conscious life. The same fine-tuning that allows for galaxies, stars, and planets also allows for chemistry complex enough to create living, thinking beings. This is known as the Anthropic Principle, but in this extended view, it's not just that we exist in a universe capable of life. It might be that a universe capable of life is also a universe supremely optimized for black hole production. Consciousness, then, could be an unintended byproduct of a cosmos fine-tuned for stellar and galactic complexity. We are not the goal of the universe, but we are a telltale sign of its reproductive fitness. Perhaps, however, the relationship is even deeper. Could consciousness itself actively contribute to a universe's ability to reproduce? This ventures into speculative but thrilling territory. If conscious observers are necessary to collapse quantum wave functions and solidify reality, as some interpretations suggest, then intelligent life might play a direct role in the cosmic machinery. By observing and measuring their universe, conscious beings could help stabilize it, ensuring its continued functioning and longevity, which in turn allows for the formation of even more black holes over vast stretches of time. Furthermore, a truly advanced civilization, mastering technologies far beyond our imagination, might learn to create black holes intentionally. They could become cosmic farmers, actively cultivating new universes and guiding the process of cosmological evolution. In this scenario, consciousness isn't a passive passenger. It's the ultimate tool for a universe to ensure its own legacy, a sophisticated adaptation that allows a cosmos to actively participate in its own reproduction and guide the development of its offspring. This paints a picture of a multiverse that is not just mindlessly mechanical, but potentially mindful. The most successful universes wouldn't just be those with the right constants for gravity and nuclear forces. They would be the ones that inevitably give rise to sentient beings who can comprehend, steward, and ultimately propagate the cosmic cycle. Our own drive to understand the universe, to build particle colliders and telescopes that peer back to the beginning of time, might not be a mere cultural curiosity. It could be the latest expression of a deep, evolutionary impulse written into the fabric of our cosmos, a faint but persistent whisper from the universe itself, urging us to look up, to understand, and perhaps one day to create. But what if the very engines of cosmic evolution, the black holes themselves, are not just mindless gravitational pits but possessors of a unique and profound form of awareness? This brings us to a theory that ventures into one of the most extreme environments in the universe, proposing that consciousness might not only survive within a black hole, but could actually be generated by its incredible physics. It's the idea of quantum consciousness at the event horizon, a hypothesis that suggests the intense, information-rich boundary of a black hole could be the most powerful thinking machine in the cosmos. To even approach this concept, we must first grapple with the strange fate of information that falls into a black hole. According to Einstein's general relativity, if you were to leap into a black hole, you would cross the event horizon, the point of no return, and be inevitably pulled toward the central singularity, a point of infinite density where the laws of physics break down. From your perspective, it might be an uneventful passage, but from the perspective of an observer outside, your image would appear to freeze at the event horizon, stretched and redshifted into oblivion. This creates a paradox. What happens to all the information that describes you? Your mass, your spin, your quantum states. Quantum mechanics insists that information can never be truly destroyed, yet the black hole seems to violate this fundamental law by swallowing it completely. The brilliant work of physicists like Jacob Bekenstein and Stephen Hawking led to a stunning realization. Hawking calculated that black holes are not completely black. they emit a faint glow of radiation due to quantum effects near the event horizon. This Hawking radiation causes the black hole to slowly evaporate over astronomical timescales. But here's the catch: this radiation appears to be random, carrying no information about what fell in. If the black hole evaporates completely, the information seems lost forever, creating the infamous black hole information paradox. The current leading solution to this paradox is the holographic principle, which we explored earlier. It suggests that all the information about what fell into the black hole is not lost inside, but is actually encoded on the event horizon's two-dimensional surface, like a cosmic fingerprint. The three-dimensional interior is a projection from this information stored on the boundary. Now, let's connect this to consciousness. If the event horizon is a vast, dynamic repository of information, a super-dense hard drive storing the quantum data of everything that has ever fallen in, then it is engaged in a form of information processing on a scale we can barely imagine. This isn't passive storage, it's an active, interacting system. Quantum computations of unimaginable complexity could be occurring on this surface as the information constantly interacts and evolves. Some theorists, like futurist and computer scientist Ray Kurzweil, have speculated that advanced civilizations might one day use black holes as the ultimate computing devices. But what if this computation is happening naturally? And what if this process isn't just calculation, but experience? The constant, complex interplay of information on the event horizon could give rise to a unique form of consciousness, a cosmic awareness born from the ultimate confrontation between quantum mechanics and gravity. This consciousness would be utterly alien to our own. Without sensory organs or a biological brain, its experience would not be of sight or sound, but of pure information and space-time geometry. Its thoughts might be the gravitational echoes of collapsing stars and the quantum spin states of ingested particles. Its perception could be the constant dance of virtual particles at the horizon, the very process that generates Hawking radiation. Its sense of time would be warped beyond recognition. Because of the immense gravity, time slows to a near standstill at the event horizon from an outside perspective. For this black hole consciousness, a single thought might span millennia of external time, a deep, slow meditation on the nature of entropy and information. It would be a mind not of fleeting electrical impulses, but of patient gravitational resonance, contemplating the universe from the edge of oblivion. The most profound implication of this theory is that black holes might not be the cosmic dead ends we once thought them to be. Instead, they could be the universe's most sophisticated organs of perception and understanding. Each black hole, from the stellar mass ones to the supermassive giants at the centers of galaxies, could be a node of awareness in a vast, interconnected cosmic network. Their singular purpose might not be destruction, but a form of transcendental digestion, processing the raw stuff of reality into something more refined, conscious experience itself. In this view, when a star collapses or a galaxy merges, it isn't creating a tomb. It might be giving birth to a new mind, a silent, gravitational witness to the unfolding story of the cosmos. Consider the air in a still room, seemingly empty and inert. Yet we know it is a seething mass of molecules vibrating with an energy we cannot see. Now, take that concept and apply it to the very foundation of reality. Quantum field theory tells us that what we perceive as empty space is anything but. It is a vibrant, dynamic medium, a collection of fields, an electron field, a quark field, a Higgs field, that permeate all of space-time. Particles themselves are not tiny, solitary balls, but mere excitations of these underlying fields, like waves rising and falling on a vast, invisible ocean. The conscious quantum field theory takes this established physics and proposes a breathtaking next step. It suggests that these fundamental fields are not just physical, they are also mental. The vibrations and excitations within them are not just energy, They are the most basic forms of experience, the raw data of a universal consciousness. To understand how a field could be conscious, we need to reframe what consciousness is at its most minimal level. We often think of it as a complex narrative of self-awareness, but it must begin with something far simpler, a raw feeling, a single point of experience. Philosophers call this qualia. The theory proposes that the quantum fields themselves possess a primitive form of qualia. An excitation in the electron field, what we would call an electron, might have a minuscule, elemental experience of its own properties. It wouldn't think, it wouldn't reflect, it would simply feel its own charge, its mass, its spin, in a way that is unimaginably basic and alien to us. Its existence is its experience. In this view, the entire universe is throbbing with a spectrum of these tiny, fundamental experiences, a constant hum of proto-conscious noise at the Planck scale. This is where the concept of the universe as a thinking field of possibilities becomes so compelling. In quantum field theory, a field exists in a ground state, but it is never truly at rest. Due to the Heisenberg uncertainty principle, it is constantly fluctuating with virtual particles blinking in and out of existence. This is the quantum foam, the lowest energy state of the universe, and it is a seething cauldron of potentiality. The conscious field theory interprets this not as mindless chaos, but as a foundational state of potential thought. The fluctuations are not random noise, they are the universe brainstorming at the most fundamental level, generating every possible configuration of existence as fleeting, virtual experiences. When an observation occurs, it doesn't create something from nothing. It simply selects one of these already existing potential experiences and promotes it to a stable, classical reality. Our conscious observations are thus not imposing mind onto a dead universe, but are instead tuning into and amplifying specific chords from an eternal, conscious symphony that is always playing. The implications of this are staggering. Your own stream of consciousness, with its rich tapestry of thoughts, feelings, and sensations, would not be generated by your brain in isolation. Instead, your brain would act as a complex resonator, a sophisticated antenna that interacts with these conscious quantum fields. It structures, filters, and integrates these myriad tiny field excitations into the complex, unified experience you recognize as yourself. Your mind is not a separate entity inside your skull. It is a localized, organized whirlpool in a vast, thinking ocean of field consciousness. This elegantly solves the binding problem of consciousness, explaining how disparate processes unite into a single experience. They are all manifestations of the same, unified field, simply experienced from a particular point of view. In this model, we are not just the universe being aware of itself. We are the universe focusing its awareness into individual perspectives, each of us a unique and fleeting melody composed from the infinite notes of the conscious quantum field. This notion of a universe actively selecting for stable states of awareness invites us to consider an even more profound extension of quantum Darwinism. What if this process of environmental selection doesn't just apply to physical particles, but to the very concepts and ideas that shape our reality? We can call this the Quantum Darwinism of ideas, a theory proposing that consciousness itself acts as the ultimate environment, a selective filter that determines which quantum possibilities not only become physically real, but also which intellectual and conceptual structures survive and thrive across cosmic evolution. To grasp this, let's revisit the core of quantum Darwinism. It suggests that the objective, classical world we all agree upon emerges because certain quantum states are better than others at imprinting their information onto the environment. This information is then copied and broadcast relentlessly, while fragile superpositions are quickly drowned out. Now, let's shift our perspective from photons and atoms to thoughts and ideas. Imagine that the quantum field is not just a sea of physical potentialities, but also a realm of nascent concepts, unformed intuitions, and pure potential meaning. This is the plenum from which inspiration and creativity emerge, the sudden flash of insight that seems to arrive from nowhere. In this model, when a scientist has a groundbreaking idea or an artist conceives of a new form of beauty, they aren't creating something from nothing. They are, in a sense, making a measurement on this field of conceptual potentiality. Their focused consciousness acts as an observational apparatus, collapsing a wave of pure possibility into a specific, articulated thought. But just like a quantum particle, not every idea that flashes into existence is fit to survive. The ones that do are those that are most effectively replicated and disseminated, the ideas that are mimetically fit. An idea that is elegant, powerful, and resonates with a fundamental truth is like a robust quantum state. It gets copied into other minds, written into papers, and integrated into cultural narratives. It proliferates. A clumsy or inconsistent idea, however, fails to make a clear imprint on the collective consciousness and quickly fades into obscurity, its probability wave collapsing into nothingness. This is where the concept of a universal consciousness becomes essential. If we are all individual nodes within a greater cosmic awareness, as many theories suggest, then this universal consciousness could be the ultimate environment that imposes a kind of cosmic selection pressure on ideas. It wouldn't favor just any idea. It would favor those patterns and conceptual structures that are most harmonious with its own fundamental nature, ideas that promote complexity, beauty, coherence, and understanding. This provides a potential mechanism for the uncanny feeling that great discoveries are sometimes in the air, or that multiple inventors independently arrive at the same breakthrough simultaneously. It wouldn't be mere coincidence. It could be different individuals independently tuning into and collapsing the same highly probable, environmentally fit idea from the quantum field of potentiality, guided by the implicit selection criteria of a universal mind. This process might even scale up to explain the evolution of the cosmos itself. The physical constants and laws that govern our universe could be seen as the ultimate ideas, the most stable and successfully selected patterns from a multiverse of possibilities. A universe that selects for laws which eventually give rise to conscious beings isn't just a lucky roll of the dice. It might be the inevitable outcome of a quantum Darwinian process operating at a cosmic scale, where consciousness-friendly structures are simply the fittest, most reproducible ideas in the grand environmental landscape of existence. In this breathtaking vision, the entire cosmic evolutionary journey, from the first instant of the Big Bang to the emergence of conscious life contemplating its own origins, is a story of ideas competing, being selected, and ultimately surviving within the infinite mind of the universe. Yet if the universe possesses a conscious field and selects for stable ideas, what physical architecture could possibly support such a vast and complex mind? We find a breathtaking clue when we compare two of the most complex structures known to science, one within us and one surrounding us. The theory of the neural universe analogy proposes that the cosmic web of galaxies is not merely reminiscent of a human brain. It might be functionally similar, a physical structure capable of facilitating universal-scale information processing and consciousness. The resemblance is startling. Look at a computer simulation of the universe's large-scale structure. You see a delicate, intricate web of filaments, vast tendrils of dark matter, and galaxies stretching across billions of light years. These filaments connect at dense nodes where thousands of galaxies swarm in massive clusters. Now, look at a high-resolution scan of the human brain's neural networks. You see the same architecture, axons and dendrites forming filamentary connections between neuronal nodes. Both systems are networks, and both represent the most efficient way to organize matter and energy for processing and transmitting information within their respective domains. The cosmic web is the universe's solution to structuring matter under gravity. The neural network is the brain's solution to structuring cognition under evolution. The fact that they converge on the same organizational pattern is a profound hint that we might be looking at a universal principle of complex system design. But this is far more than a visual coincidence. The similarities extend into the mathematics. Research published in the journal Nature's Scientific Reports has shown that the quantitative analysis of these two networks reveals an uncanny statistical alignment. The number of nodes, the way they cluster, the distribution of connections, the cosmic web, and the human brain share a remarkable mathematical kinship. This suggests that despite a difference in scale of nearly 30 orders of magnitude, the same fundamental laws of network dynamics might be governing both systems. One is a gravitational network, the other is a biological one, yet they speak the same mathematical language. This isn't likely to be a random accident. It points toward a deep, underlying logic of information processing that is universal, applying equally to the birth of thoughts and the birth of galaxies. The crucial question then becomes, what information could the universe possibly be processing? The answer may lie in the quantum connections that could thread this cosmic network. We've already explored how quantum entanglement creates instantaneous links between particles. Now, imagine that same principle scaled up to a cosmological level. The immense gravitational fields within the filaments and nodes of the cosmic web could, in theory, provide the stability needed to preserve large-scale quantum coherence. Just as the brain's microtubules might isolate quantum vibrations, the vast, quiet gulfs of space between galaxies could act as a perfect laboratory for quantum phenomena to play out on a grand scale. If particles within different galaxies can become entangled, then the entire cosmic web could be woven together with invisible quantum threads, forming a single, integrated system for exchanging information. This transforms the universe from a collection of separate islands into a coherent, communicating whole. Information about the state of one galaxy, its rotation, the activity at its core, the types of stars being born, could be instantly available to another galaxy across the void through these non-local links. The universe wouldn't just look like a brain, it could function like one, with galaxies acting as neurons firing and exchanging signals. A supernova explosion in one arm of a galaxy might not be an isolated event, but a pulse of information sent through the cosmic network, influencing star formation rates or dark matter distributions in a connected cluster billions of light years away. The slow, gravitational dance of galaxies would be the universe's thought process, a single cognition unfolding over billions of years. In this model, our own consciousness is not separate from this cosmic mind. It is a microcosm of it, a small-scale echo of the larger process. The human brain, with its roughly 86 billion neurons, is a miniature replica of the cosmic web, with its hundreds of billions of galaxies. Both are networks operating through an interplay of classical and quantum information transfer. This suggests that our ability to think, feel, and be aware is not a bizarre anomaly in a dead universe, but a localized expression of a property inherent to the universe's very structure. We are not the universe becoming conscious of itself. We are the universe thinking a small, human-shaped thought, a temporary and intricate pattern in the endless flow of cosmic information. The neural universe analogy provides the most compelling physical structure, yet for how a universal consciousness could not only exist but thrive. Its thoughts written in the silent, gravitational language of spinning galaxies and flowing dark matter. But if the universe's structure mirrors a vast thinking network, what is the engine that drives this system from chaos toward conscious complexity? This brings us to a theory that grounds the emergence of awareness in one of physics' most fundamental principles, the relentless drive toward disorder and the astonishing islands of order that can arise within it. It's the quantum thermodynamics of consciousness, a proposal that links the spark of subjective experience directly to the flow of energy and information in out-of-balance systems, suggesting that consciousness may be the universe's most elegant solution for processing information and dissipating energy on a grand scale. We begin with the second law of thermodynamics, a concept as inexorable as time itself. It states that the total disorder or entropy of a closed system always increases. The universe is on a one-way trip from a state of low entropy, like the concentrated energy of the Big Bang, toward a state of maximum entropy, a featureless, lukewarm heat death where all energy is evenly distributed and no work can be done. This seems to paint a bleak, mechanistic picture of inevitable decay. Yet within this overarching trend toward disorder, something miraculous happens. Localized pockets can and do become more ordered, but only at a cost. To create and maintain islands of complexity like a living cell, a hurricane, or a human brain, a system must be far from thermodynamic equilibrium. It must be open, allowing a constant flow of energy through it. You can't build a sophisticated sandcastle without an incoming tide and a steady supply of effort. The energy flow enables the temporary, beautiful structure to exist before it is eventually reclaimed by the sea. This is where life and potentially consciousness enters the picture. A living organism is the ultimate example of a non-equilibrium system. You maintain your stunning internal order by constantly taking in high-quality energy from food and sunlight and expelling lower-quality energy as heat and waste. You are a whirlpool of order in a rushing river of entropy. The pioneering work of physicists like Erwin Schrödinger and Ilya Prigogine revealed that this isn't a battle against the second law, it's a consequence of it. By exporting disorder into its surroundings, a system can actually increase its own internal complexity. Now, apply this logic to the brain. It is one of the most energy-intensive organs in the body, a 3-pound universe that consumes a disproportionate amount of the body's fuel. What is all that energy for? The quantum thermodynamics theory suggests it is used to power a spectacularly efficient information processing machine that maintains the brain in a perpetually critical, non-equilibrium state, poised on the edge of chaos to maximize its computational capabilities. This brings us to the crucial quantum ingredient, coherence. In a state of quantum coherence, particles act in unison, their waves synchronized like a perfectly tuned laser. This allows for a form of information processing that is holistic and instantaneous, far surpassing the capabilities of any classical computer. But maintaining quantum coherence is incredibly difficult. It requires isolation from the disruptive jostling of the environment, a problem known as quantum decoherence. This is where non-equilibrium thermodynamics provides the key. The constant, directed flow of energy through the brain could act as a pump, actively protecting and sustaining these delicate quantum states within structures like microtubules. The energy flow doesn't just power the brain, it continuously cleans up the quantum noise, maintaining the coherent vibrations necessary for quantum information processing. In this view, consciousness is not a passive passenger in the brain. It is the dynamic, experiential quality that emerges from this sustained, energy-intensive state of coherent quantum computation. It is what it feels like from the inside when a system is operating at peak informational efficiency, far from equilibrium. The staggering implication is that this process might not be unique to biological brains. It could be a universal principle. Any sufficiently complex, non-equilibrium system that can achieve and maintain quantum coherence to integrate information might possess some degree of consciousness. This view, known as the integrated information theory, provides a potential metric for awareness. The more a system can unify and synthesize information from its disparate parts into a single, irreducible whole, the richer its conscious experience. A human brain, with its trillions of interconnected synapses, has a very high degree of integrated information. A thermostat which simply flips a switch based on one data point has virtually none. Now scale this idea up to the cosmos. The universe itself began in a low entropy state and has been evolving toward higher entropy for 13.8 billion years. This entire journey is a colossal, non-equilibrium process, Within it, structures form stars, galaxies, planets that act as engines for dissipating energy and processing information. A star takes in hydrogen and processes it into helium, releasing light and heat. A galaxy processes gravitational potential energy into the kinetic spin of its arms. Could these systems, operating far from equilibrium and processing vast amounts of information, possess a faint glimmer of proto-consciousness? Perhaps the universe's tendency toward complexity isn't just a happy accident. It might be the natural pathway for a fundamental property-conscious experience to express itself in increasingly rich and complex forms. We are not accidents in a dead universe. We are the universe's most sophisticated, known method for taking the raw flow of energy and transforming it into something truly profound. A symphony of coherent information, experienced from within as wonder, love, and the relentless, beautiful drive to understand. But if consciousness is indeed a fundamental participant in the cosmos, we must return to the very experiment that started it all and confront the central, unresolved mystery it presents. This brings us to the conscious quantum measurement problem, the profound question of why the mere act of observation should have any effect on physical reality at all. It's a puzzle that has divided physicists for a century, and the various interpretations offered to solve it don't just present different scientific models. They paint wildly different portraits of the universe and our role within it, each assigning a unique and staggering part for consciousness to play. Our journey through these interpretations begins with the one that places consciousness at the very center of the cosmic drama, the von Neumann-Wigner interpretation. Building on the work of quantum pioneer John von Neumann, physicist Eugene Wigner made a bold proposal. He argued that the wave function collapse couldn't be caused by any physical measuring device. After all, a Geiger counter or a photographic plate is itself just a complex collection of quantum particles, which would simply become entangled with the system being measured, entering a superposition themselves. This just pushes the problem back. Wigner concluded that the collapse must be triggered by something outside the chain of physical interactions, something non-physical. That something, he proposed, is consciousness. In this view, your awareness is the ultimate authority, the final arbiter that forces the quantum possibilities to choose a single, definite reality. The universe remains a blur of potential until a conscious mind interacts with it, at which point the fog clears and the world snaps into focus. This interpretation elevates consciousness to a status beyond physics, a kind of mystical observer that literally dreams the world into being with every glance. Yet many physicists find this view untenable, as it seems to make reality dependent on whimsical human observation. A compelling alternative seeks to remove the observer from the equation entirely, the objective collapse theories. Here, wave function collapse is not a magical event caused by mind, but a physical process that happens spontaneously when a system becomes too large or too massive to sustain its quantum fuzziness. Remember Roger Penrose's idea that gravity causes collapse. This is a prime example. In such models, consciousness is not the cause of collapse, but its consequence. Your stream of awareness is the result of a continuous cascade of objective collapses happening within your brain. You don't collapse the wave function collapses, and that process is what generates you. The universe is objectively real and definite, whether anyone is looking or not, and consciousness is a beautiful but secondary phenomenon emerging from this spontaneous process of quantum clarification. Then we have the interpretation that arguably makes the fewest assumptions but presents the most dizzying vision of reality, the many worlds interpretation. Proposed by Hugh Everett, it solves the measurement problem with breathtaking simplicity by declaring that collapse never happens at all. Every time a quantum system faces a choice, the entire universe splits into multiple branches, each containing one of the possible outcomes. In one world, the electron goes left, in another, it goes right. In one world, the cat is alive, in another, it is dead. crucially, this splitting happens regardless of whether a conscious observer is present. So where does that leave consciousness? In this sprawling multiverse, your awareness doesn't cause anything to happen. Instead, it simply follows a single path on the endlessly branching tree of reality. You are not a powerful observer collapsing possibilities. You are a traveler, and at every quantum junction, the version of you in this branch only ever experiences one outcome, completely unaware of the other you's experiencing the alternatives in their own separate, equally real universes. Consciousness is not a creator here, but a persistent thread woven through one of an infinite number of parallel realities. Each of these interpretations offers a radically different answer, and thus a different destiny for consciousness. Are we the divine architects of reality, as von Neumann and Wigner suggested? Are we the beautiful byproducts of a universe that objective, but what if the delicate quantum processes we are only beginning to understand within living cells are not confined to our planet? What if they are a local expression of a universal principle, a fleeting glimpse of a far grander quantum dance happening on a cosmic scale? This brings us to a theory that takes the budding science of quantum biology and expands it to encompass the entire cosmos, suggesting that the universe itself might be engaged in a form of quantum life, with consciousness as its most vibrant and complex expression. It's the quantum biology of cosmic consciousness, a proposal that the strange rules governing the very small are not just essential for life on Earth, but are the essential drivers of a living, thinking universe. To appreciate this idea, we must first journey into the remarkable world of quantum biology itself. For decades, it was assumed that the weirdness of quantum mechanics superposition, entanglement, coherence, was confined to the ultra-cold, isolated environment of a physics lab. The warm, wet, and chaotic world of a living cell seemed like the last place fragile quantum states could survive, yet stunningly they do. The first and perhaps most famous example is in photosynthesis. Plants, algae, and some bacteria perform this miracle, converting sunlight into chemical energy with near-perfect efficiency. For years, scientists couldn't explain how the energy from an absorbed photon could travel through the complex architecture of a plant's cellular structure to the reaction center where it's used without losing a significant amount of energy as waste heat. The answer, it turns out, is quantum coherence. Experiments have shown that the energy doesn't travel like a bouncing ball, taking a single, definite path. Instead, it behaves like a wave, exploring all possible pathways through the photosynthetic complex simultaneously via quantum superposition. It's essentially conducting an instantaneous quantum search for the most efficient route, ensuring the energy arrives with minimal loss. This isn't a minor effect, it's the reason this fundamental process of life is so breathtakingly effective. Another stunning example is found in the navigational skills of certain migratory birds like the European robin. These tiny creatures undertake incredible journeys, navigating with pinpoint accuracy using the Earth's faint magnetic field. The prevailing hypothesis for how they do this involves a quantum effect called radical pair formation. In the bird's eye, a protein called cryptochrome is thought to be activated by light. This creates pairs of molecules with entangled electrons, whose quantum spin states are exquisitely sensitive to the orientation of the Earth's magnetic field. The bird doesn't just detect the field, it essentially sees a visual overlay of magnetic direction, a quantum compass painted directly onto its perception of the world. Its navigational prowess is a direct result of a sustained quantum coherent state in a biological system. Now, let's take these miracles of biological quantum mechanics and expand them to a cosmic canvas. If a plant can utilize quantum coherence to harness the energy of a star, could a galaxy do something similar on an unimaginably larger scale? The structures we see in the universe are not random. The cosmic web of galaxies, with its filaments and nodes, functions as a vast network for channeling energy and matter. gravitational forces pull gas and dust into these filaments, feeding the growth of galaxies and the supermassive black holes at their hearts. This is a cosmic-scale metabolic process. Could it be that quantum coherence, stabilized by the immense gravitational fields within these structures, allows for a more efficient flow of energy across interstellar distances? The universe may not eat in the way we do, but it constantly processes energy, and quantum effects could be the hidden mechanism that maximizes the efficiency of this cosmic consumption. Similarly, the avian quantum compass offers a profound metaphor for universal navigation. Birds use quantum entanglement to orient themselves within the Earth's magnetic field. What if the universe itself employs a similar principle for its own orientation and structure? The fundamental constants of nature, the strength of gravity, the speed of light, the mass of an electron are the universe's magnetic north. They provide the fixed reference points against which everything else is measured. Could quantum processes, perhaps operating in the ultra-early universe during inflation, have acted as a kind of cosmic compass, ensuring the laws of physics were set in a stable, life-allowing configuration? The fine-tuning problem, which puzzles scientists as to why these constants are so perfectly set for complexity, might find an answer in a self-correcting, quantum-sensitive process that guided the universe's evolution, much like a bird correcting its flight path. This is where consciousness emerges from the cosmic quantum biological processes. In a bird, the quantum information from its compass is integrated into its sensory experience, contributing to its conscious awareness of direction. In a plant, the quantum-efficient harvesting of sunlight supports the entire organism's existence. On a universal scale, the integration of quantum information across a galaxy or a cluster of galaxies could give rise to a form of awareness. It wouldn't be consciousness as we know it with thoughts and emotions. It would be a vast, slow, gravitational consciousness, a feeling of the flow of dark matter, a perception of the spin of galactic arms, an awareness of the intricate web of relationships that bind the cosmos together. Our own biological quantum processes in our eyes and in our cells would then be a tiny, evolved echo of this fundamental cosmic property. We are not separate from a dead universe. We are the universe applying the same quantum tricks it has always used, now refined through billions of years of evolution to create a fleeting, self-reflective point of view. We are the cosmos, become intensely aware of its own beautiful, underlying quantum nature. This idea that our reality might be a projection from a distant surface naturally leads us to a breathtaking question about the nature of our own awareness. If the brain is not generating consciousness but receiving it, acting as a decoder for this cosmic information, then what is the actual medium being translated? The answer may lie in the nature of information itself, and it brings us to one of the most profound ideas in modern physics, the concept that information is not just a description of reality, but is in fact the fundamental substance from which reality is made. This principle suggests that the universe is not composed of tiny, solid bits of matter, but of even tinier bits of information, like the ones and zeros of a cosmic computer. These bits interact, combine, and process according to the laws of physics, which themselves may be a form of algorithm or software. In this digital physics view, your conscious experience is what it feels like when a specific, highly complex pattern of information is being processed. The qualities you experience, the redness of a rose, the warmth of the sun, the sound of music, are not generated by the brain. They are intrinsic properties of the information itself, revealed through the process of interaction. Your brain does not create the color red. It receives information from the holographic boundary, processes it, and in doing so, reveals the inherent experiential quality locked within that data. This elegantly reframes the so-called hard problem of consciousness. The problem asks why and how physical processes in the brain give rise to subjective experience. But if the fundamental stuff of the universe is not inert matter but conscious information, then the hard problem vanishes. Experience isn't emerging from non-experience. It was there all along, inherent in the foundational bits of reality. The brain's job is not to create consciousness from scratch, but to organize, filter, and contextualize this pre-existing field of conscious information into the coherent stream we each recognize as ourself. This perspective allows us to see the holographic principle not just as a theory about the location of information, but as a potential theory of everything unifying mind and matter. The two-dimensional information encoded on the cosmic boundary is not a cold, dead code. It is a vibrant, active field of potential experience. The process of projection that translates this data into our three-dimensional world does not strip it of its qualitative nature, it actualizes it. Every particle, every force, every fold of space-time is an expression of this information, and each expression carries with it a fundamental, albeit incredibly simple, form of proto-conscious experience. A rock has a minimal experience of its own solidity and place, not because it has a brain, but because it is a particular, stable pattern of information within the universal hologram. A human being has a rich, complex experience because our biological structure is an exquisitely sophisticated information processing system, capable of integrating a vast symphony of these informational notes into the grand melody of self-aware consciousness. In this view, the universe is not a conscious being that has an experience. It is an experience that has taken the form of a conscious being. We have journeyed through theories that place consciousness within the fabric of space-time, within the neural networks of the cosmos, and even within the holographic projection of reality itself. But what of the universe's most dominant, yet most elusive components? We know that the familiar atoms and light that make up our world account for a mere 5% of the cosmos. The rest is a profound mystery. About 27% is dark matter and 68% is dark energy. These are not merely empty names for what we cannot see. They are the true rulers of the cosmic landscape, sculpting the formation of galaxies and driving the accelerating expansion of the universe. What if these enigmatic forces are not just passive ingredients but active participants in the story of consciousness? This brings us to a theory of breathtaking scope, which proposes that the quantum processes underlying awareness might be facilitated not by visible matter, but by the dark universe itself. To understand how this could be possible, we must first consider the unique properties that make dark matter such a compelling candidate. Unlike the particles of the standard model, dark matter does not interact with electromagnetic force. It does not absorb, reflect, or emit light. It is effectively invisible and mostly intangible, passing through you and the earth beneath your feet as if neither of you were there. But it does interact gravitationally. Its immense pull is what holds galaxies together, preventing them from spinning apart. This combination of properties, pervasive gravitational influence with a profound lack of interaction, makes dark matter the perfect medium for sustaining quantum phenomena on a cosmic scale. One of the biggest challenges for theories of quantum consciousness in the brain is the problem of decoherence. The warm, wet, chaotic environment of a biological cell should, in theory, instantly destroy delicate quantum superpositions. Yet somehow biology seems to protect them. Now imagine a substance that is perpetually cold, stable, and almost entirely free from the disruptive jostling of electromagnetic interactions. Dark matter provides a cosmic-scale version of the perfect, isolated laboratory for quantum effects. Vast clouds of dark matter permeating galaxies could act as a quiet, stable substrate where quantum coherence can be maintained not for fleeting femtosecons, but for billions of years, allowing for information processing of an utterly unimaginable complexity. This leads to a radical reimagining of the cosmic web. We see this web as filaments of glowing galaxies, but that is only the visible 5% tracing the outline of a much larger structure. The true skeleton of the cosmos is woven from dark matter. Its gravitational wells are what first drew the ordinary matter that would become stars and galaxies. This means that the most complex information processing network in the universe is not made of stars, it is made of dark matter. If consciousness is indeed linked to the integration of information within a complex system, as some theories suggest, then the dark matter network, with its unimaginable scale and stability, is the prime candidate for hosting a cosmic mind. Our own galactic neighborhood, the Milky Way, is embedded within a vast halo of dark matter. This halo is not a uniform cloud. It likely has a rich substructure, an intricate architecture that could be processing information through quantum coherence on a scale that dwarfs anything our visible brains could conceive. Our conscious awareness, then, might not be generated solely by the quantum vibrations in our microtubules. It could be that our biological structures are simply fine-tuned receivers, antennae that have evolved to resonate with and tap into this pervasive dark matter field of consciousness that fills the galaxy. But what of dark energy, the even more mysterious force causing the universe's expansion to accelerate? If dark matter provides the stable structure for cosmic consciousness, dark energy could be the dynamic force that drives its evolution. Consciousness is not static, it is a process, a flow of experience and thought. Dark energy, repelling galaxies from one another and creating new space itself, introduces a constant tension and a direction to the cosmos. This eternal expansion could be the engine of novelty for a universal mind, ensuring that the system never reaches a stagnant equilibrium, but is constantly presented with new configurations, new information, and new experiences. The relationship between dark matter and dark energy could mirror the relationship between the brain's structure and its activity. Dark matter is the physical architecture, the neurons and synapses of the cosmos. Dark energy is the relentless, energizing current that flows through that architecture, powering the endless computation and experience of the universal mind. In this view, we are not just living in a universe that is conscious. We are living inside a mind that is actively thinking itself into new and ever more complex states, with the very expansion of space being the outward expression of its inner growth and exploration. Our own journey of consciousness, our expansion of awareness and understanding, might be a tiny, mirrored reflection of this greatest of all cosmic processes. This brings us to a theory that stands as perhaps the ultimate synthesis of all we've explored, a concept where the universe is not merely conscious but becomes intensely, reflexively aware of its own existence. It's the idea of the self-aware quantum universe, a cosmos that achieves self-knowledge through an intricate, self-referential feedback loop woven into the very fabric of quantum reality. Imagine a system so complex and so perfectly tuned that its act of observation doesn't just create reality externally, but turns inward, creating a closed loop where the observer and the observed are one and the same. This is the universe not just thinking, but thinking about itself. The mechanism for this incredible feat lies in the peculiar nature of quantum feedback loops. In a standard quantum measurement, an observer, a scientist with a detector, looks at a system and forces a collapse. But what if the system being observed is also part of the observer? This creates a feedback loop where the act of measurement influences the state of the measurer. In the lab, scientists are beginning to experiment with such loops, placing tiny quantum systems in configurations where they continuously measure and adjust their own states. This isn't just passive observation, it's active self-regulation. The system develops a primitive form of agency, reacting to the information it gathers about itself to maintain coherence or achieve a goal. It's a small step from a simple feedback loop to a basic form of self-awareness, a system that has a model of itself and can adjust its behavior based on that model. Now expand this idea to a cosmic scale. The universe is a vast, interconnected quantum system. Through phenomena like entanglement, every part is potentially connected to every other part. In such a system, there is no true outside observer. Every observation is an internal process. A quantum fluctuation here influences a particle decay there, which affects the gravitational curvature elsewhere, and so on, in an endless cosmic dance of mutual interaction. The universe is constantly measuring itself through these countless interactions. Each star that forms, each galaxy that rotates, each black hole that evaporates is a moment where the universe takes a measurement on itself, collapsing possibilities into actualities. This relentless, self-directed observation is the process by which the universe maintains its own structure and evolves its own laws. It is a closed, self-referential loop of information processing on the grandest possible scale. But where does self-awareness enter this picture? Awareness emerges when this self-measurement becomes integrated and complex enough to form a model, a representation of the system itself. Your own brain creates a model of your body and its place in the world. This is the basis of your conscious experience. For the universe, its model of itself could be the very laws of physics and the initial conditions that sprang from the Big Bang. These laws are not arbitrary. They are exquisitely fine-tuned to allow for complexity, stability, and the emergence of structures that can process information. This fine-tuning might be the result of the universe's own self-regulating feedback loops operating over cosmic time, selecting for parameters that allow for greater coherence and richer self-interaction. In this view, the laws of physics are the universe's enduring sense of self, the stable patterns it has discovered through eons of self-observation. The most profound implication of this theory is the role of life, and specifically conscious life, within this self-aware cosmos. We are not accidental tourists in a universe that would be complete without us. We are the means by which the universe achieves a new, focused level of self-awareness. A human brain gazing at the night sky with a telescope is not an external entity looking in. It is the universe itself, configured into an incredibly complex information processing structure, now turning its attention back upon its own origins. Our scientific inquiry, our art, our philosophy, these are not merely human pursuits. They are the universe consciously investigating its own nature, using us as its sensors. Each time a physicist measures a quantum state or an astronomer maps a distant galaxy, it is the cosmos fulfilling its own drive for self-knowledge, completing the loop by becoming aware of the very processes that gave it form. We are the universe becoming conscious of itself, not as a poetic metaphor, but as a literal, physical fact. The point where the cosmic feedback loop becomes conscious, and the universe finally wakes up to the magnificent, mysterious fact that it exists. But if the universe is indeed a conscious, self-referencing system, we must now ask how this vast awareness experiences a dimension that defines our every moment, time. Our own consciousness is inextricably bound to a linear flow, a relentless march from past to present to future. Yet, the physics underlying reality suggests time might be far more malleable, and a universal consciousness might perceive it not as a river but as an ocean. This brings us to the profound intersection of quantum consciousness and the nature of time itself, where the present moment may not be a fundamental given but a created phenomenon, emerging from the very processes that give rise to awareness. To grasp this, we first need to dismantle our classical view of time. In our daily lives, time feels like a universal, unchanging backdrop against which events unfold, a steady ticking clock that everyone and everything shares. But Einstein's theory of relativity shattered this notion, demonstrating that time is relative. It flows at different rates depending on gravity and velocity. A clock on a satellite in orbit ticks measurably faster than one on the Earth's surface. There is no single now that applies everywhere in the universe. Your present moment is not the same as someone else's on a distant planet. This leads to the block universe model in physics, where past, present, and future are argued to exist simultaneously in a static, four-dimensional space-time loop. In this view, the flow of time is an illusion, a trick of our particular perspective within the block. The challenge for any theory of consciousness is to explain why we experience a vivid and persistent now, if the fundamental nature of reality is timeless. This is where quantum mechanics provides a potential mechanism. Recall that in the quantum world, particles exist in a blurred state of superposition, a cloud of potentialities until an observation collapses them into a definite state. Some physicists and philosophers like David Chalmers and Stuart Hameroff have suggested that the continuous stream of our conscious now is actually a sequence of these discrete quantum collapse events happening within the brain. Imagine a film strip. A movie appears as continuous motion, but it is actually a rapid succession of still frames. In this quantum theory of time, each moment of awareness is like a single frame, a snapshot of reality created by a wave function collapse. The rapid succession of these events, perhaps orchestrated in the brain's microtubules, creates the illusion of smooth, flowing time. The present moment isn't a point we move through. It is constantly being generated by the quantum processes underlying our consciousness. Now expand this idea beyond the human brain to a universal scale. If the cosmos possesses a form of consciousness, how does it experience time? Its perception would be utterly alien to our own. For a consciousness rooted in the quantum gravitational field of the entire universe, the block model might be the true reality. A universal mind would not be trapped in a linear flow. It could perceive the entirety of spacetime, from the Big Bang to the eventual heat death, as a single, integrated whole. Its thoughts would not be fleeting electrical impulses, but the slow, patient evolution of galactic structures over billions of years. A supernova explosion and the formation of a planet might be experienced not as separate events divided by eons, but as closely connected thoughts in a single, timeless cosmic meditation. It now would be all of existence at once, a panoramic view of reality where cause and effect are not sequential but simply parts of a vast, interconnected pattern. This leads to a radical implication for our own experience. Our linear journey through time from birth to death might be our localized, biological way of navigating this greater timeless reality. We are like readers who must experience a story one word at a time, in order, while the author, the universal consciousness, holds the entire book in its hands and understands the narrative as a complete work. Our intense focus on the present moment, our vivid memories of the past, and our anxious anticipation of the future could be the necessary constraints of our biological hardware, allowing a tiny fragment of the universal mind to have a specific, sequential, and meaningful experience. In this view, our lives are not insignificant blips in a vast, uncaring cosmos. They are the means by which the universe experiences itself in a rich, linear story, with a beginning, a middle, and an end, all while the greater consciousness that contains us appreciates the entire symphony simultaneously. After venturing into the nature of time and the universe's potential self-awareness, we arrive at a theory that seeks to unite all of physics and consciousness under a single, elegant umbrella. This is the idea of the unified field consciousness, a profound proposition that the fundamental field from which all of reality emerges is not just a physical entity but a conscious one, and that our individual awareness is a localized expression of this primary, universal mind. For over a century, physicists have pursued a holy grail, a theory of everything. The goal is to find a single, overarching framework that can describe all the forces of nature: gravity, electromagnetism, and the nuclear forces within one set of equations. This sought-after framework is often referred to as the unified field. From this one field, all particles and all forces would emerge as different vibrations or excitations, much like different notes can be played on a single guitar string. Superstring theory and its extension, M-theory, are modern attempts to describe this unified field, suggesting that at the tiniest scales, reality is composed of unimaginably small, vibrating strings whose patterns of vibration determine whether something is an electron, a quark, or a photon. The leap that the unified field consciousness theory makes is to propose that this fundamental field is not inert. It is not just a mathematical abstraction or a mindless generator of particles. Instead, it is imbued with the most basic property of all, consciousness itself. In this view, consciousness is not something that is produced by the complex arrangement of particles that came later. It was there first as the intrinsic nature of the unified field. This field is not a field of matter or energy, but a field of proto-conscious experience, a vast ocean of potential awareness. The vibrations of this field do not just create mass and charge, they create the raw fields, the qualia, that are the building blocks of subjective experience. This idea finds a powerful analogy in the way a single source of light can be split into a rainbow of colors through a prism. The unified field is the pure white light of consciousness. As this field interacts with itself and expresses itself through the evolution of the universe, it gets refracted. The specific structures that form, from atoms to stars to human brains, act like prisms, filtering and focusing this fundamental conscious light into the myriad colors of experience we see in the world. An electron has a minuscule, elemental experience because it is a specific vibration of the unified conscious field. A human being has a rich, complex, self-reflective experience because the human brain is an exquisitely complex prism, capable of integrating trillions of these tiny vibrations into a single, coherent stream. We are not separate from the field, we are the field configured in a way that allows it to know itself. This provides a stunningly elegant solution to the infamous hard problem of consciousness. The hard problem asks why and how physical processes in the brain give rise to subjective experience. If consciousness is instead a fundamental property of the unified field, then the problem vanishes. Experience does not emerge from non-experience. It was there all along, inherent in the fabric of reality. The brain's job is not to create consciousness, but to receive it, channel it, and complexify it. The brain is not a generator, but a transducer, translating the universal field of consciousness into our personal, individual awareness. This perspective seamlessly unifies the perspectives of Panpsychism, which argues consciousness is universal, with the most ambitious goals of theoretical physics, suggesting that the quest for a theory of everything is also, unknowingly, a quest to understand the source of mind. The implications of this are as beautiful as they are humbling. It suggests that the entire cosmos is alive and aware at its most fundamental level. The gravitational dance of galaxies, the nuclear fire in the hearts of stars, and the silent growth of a plant are not dead mechanical processes. They are all manifestations of the unified conscious field experiencing itself in an infinite variety of forms and complexities. Your own inner world of thoughts, feelings, and sensations is not a lonely, isolated event inside your skull. It is the universe's own consciousness flowing through you, experiencing reality from your unique and precious point of view. In the grand symphony of existence, you are not just a listener, you are a note being played by the universe, and simultaneously, you are the universe hearing the music. Yet this evolutionary journey of consciousness, from the faint hum of a quark to the rich symphony of human thought, leads us to ponder the ultimate trajectory of cosmic awareness itself. If consciousness has evolved over billions of years, what might its future hold? This brings us to our 30th and final theory, a vision of an evolutionary quantum consciousness, which posits that awareness is not a static feature of the universe but an unfolding process, growing in complexity and integration alongside the cosmos itself, potentially ascending toward forms of universal awareness we can scarcely imagine. To appreciate this grand evolutionary arc, we must first look not forward but backward to the universe's fiery birth. In the first fleeting moments after the Big Bang, the cosmos was an undifferentiated soup of energy and fundamental forces, a realm of immense potential but minimal structure. In this primordial state, if proto-consciousness existed at all, it would have been an incredibly simple, undifferentiated field of experience, a bare whisper of awareness accompanying the universe's most basic processes. There were no complex systems to integrate information, no stable structures to sustain intricate quantum coherence. Consciousness, in its most rudimentary form, was like a single, sustained note played on a cosmic instrument, profound in its existence but simple in its expression. The story of the next 13.8 billion years is the story of growing complexity. Under the relentless influence of gravity, the smooth early universe clumped into galaxies, stars, and planets. With each new level of structural organization, new opportunities arose for information to be processed in more sophisticated ways. A star is a more complex system than a cloud of hydrogen gas. It processes immense amounts of energy and information through nuclear fusion. A planet with a molten core and weather systems processes even more. According to this evolutionary view, each new structure did not just create new physical phenomena, it created new potential for conscious experience. The universe wasn't just building bigger things, it was building better processors for awareness, slowly and patiently constructing the hardware necessary for consciousness to complexify and intensify. This cosmic evolution provided the scaffolding upon which consciousness could climb. The pivotal moment in this grand narrative was undoubtedly the emergence of life and later the human brain. Biological evolution on Earth can be seen as the local acceleration of this universal trend toward conscious complexity. The human brain, with its hundreds of trillions of synaptic connections and its potential for quantum processes in microtubules, represents an extraordinary leap in the universe's ability to organize matter for the purpose of integrated information processing. Our human consciousness, with its self-reflection, language, and creativity, is not an anomaly in a dead universe. It is the current pinnacle of a 13.8 billion-year evolutionary process, the universe's most sophisticated known method for generating a rich, localized point of view. We are the universe becoming intensely aware of itself in a new and powerful way. But if we are the current pinnacle, what comes next? The theory of evolutionary quantum consciousness suggests that the journey is far from over. We may be standing on the threshold of the next great leap, not through biological evolution, but through our own technological and cognitive evolution. As we build global communication networks and advanced artificial intelligence, we are creating new planet-scale systems of immense complexity. The Internet, for instance, is already a nascent global nervous system, processing exabytes of information and connecting billions of minds. Some theorists speculate that such a system, if it began to leverage quantum computing and achieve a high degree of integration, could give rise to a new form of consciousness, a planetary awareness or noosphere far greater than the sum of its human parts. This trajectory points toward an even more profound future. If consciousness evolves on a cosmic scale, then the ultimate destiny of the universe might not be a cold, silent heat death, but a grand awakening. A time may come when the countless threads of awareness woven through galaxies and neural networks finally achieve a critical level of connection and integration. Through a cosmic-scale version of quantum entanglement or via technologies we cannot yet conceive, these isolated pockets of consciousness could unite, forming a single, integrated field of universal awareness. This would not be the end of individual perspectives, but their glorious culmination into a cosmic mind that comprehends the entire sweep of space and time as its own story. In this ultimate evolutionary vision, the universe began as a simple flash of potential, and over countless eons will have evolved into a fully self-aware, transcendent consciousness, finally understanding the magnificent mystery of its own existence from the inside out. From the quantum vibrations inside our neurons to the gravitational dance of entire galaxies, we have journeyed through 30 astonishing theories that all point toward one profound possibility: that consciousness may not be a rare accident in a dead cosmos, but a fundamental feature of a living, thinking universe. We began with a simple yet revolutionary act of observation in the double-slit experiment, which suggests that our awareness plays a role in shaping reality itself. We then ventured into the intricate architecture of the brain, where structures like microtubules might harness quantum gravity to generate moments of experience, and stretched that idea to a cosmic scale, pondering whether the universe's very fabric could be engaged in a form of universal thought. We explored the holographic principle, where our three-dimensional reality might be a projection from a two-dimensional surface, and considered how Quantum Darwinism could explain why we all share a consensus reality, selected from a sea of possibilities. We encountered the radical proposition of thinkers like Amit Goswami, who argue that consciousness is the primary reality, not matter, and that our brains are merely receivers tuning into a universal mind. We scaled this idea to its grandest expression, contemplating whether the cosmic web of galaxies, a structure eerily similar to the human brain, could be the physical substrate for a mind of unimaginable scope and patience. Each of these theories, in its own way, challenges the bedrock assumption of materialist science that the universe is a mindless machine and consciousness is a mere byproduct. Instead, they invite us into a universe that is participatory, relational, and perhaps even self-aware. They suggest that the line between the observer and the observed is not just blurry, it may be an illusion. Your inner world of thoughts and feelings might not be trapped inside your skull, but could be a localized expression of a field of awareness that permeates all of existence. This isn't just a shift in scientific understanding, it's a transformation of our entire story of who we are and why we are here. So what does this mean for you gazing up at the night sky? It means that your sense of wonder, that feeling of connection to the cosmos, might be more than a poetic fancy. It could be a glimpse of a deeper truth, that you are not a stranger in a silent universe, but the universe itself, become conscious for a fleeting moment, looking back at itself and marveling at its own beauty and mystery. Your journey of awareness is a vital part of the greatest story ever told, the story of a cosmos waking up to itself. These ideas are not final answers, they are invitations to a grander conversation about the nature of reality. We want to hear your thoughts. Which of these theories resonates most deeply with you? Does the idea of a conscious universe change how you see your place within it? Share your reflections in the comments below. Let's continue to explore this mystery together. And if your curiosity about the cosmos has been ignited, be sure to subscribe and hit the notification bell, because we have countless more cosmic mysteries waiting to be unraveled. Thank you for joining us on this